Imagine something so powerful, so unimaginably violent, that it can outshine entire galaxies in an instant. A cosmic explosion so intense that it shakes the very fabric of space itself, sending out energy far beyond anything we can truly comprehend. These are not just your everyday supernovae. These are hypernovae, the largest and most extreme stellar explosions in the universe. But what causes them? What makes them so different from a regular supernova? And are they the most powerful cosmic events out there? Or is there something even more extreme lurking in the darkness of space? Space is full of mysteries, but the most violent and energetic ones often go unnoticed because they happen in the distant reaches of the universe, too far for the naked eye to see. But if you could witness a hypernova up close, it would be one of the most terrifying and awe-inspiring sights imaginable. The sheer scale of destruction, the mind-bending forces at play, and the energy released in just a few seconds would make the biggest nuclear explosions on Earth look like nothing more than a tiny spark. But how do these explosions happen? To understand hypernovae, we first need to look at the life cycle of stars. Not all stars are created equal. Some are small and dim, like red dwarfs, which burn for billions, sometimes even trillions, of years. Others, like our Sun, have a lifespan of around 10 billion years before they run out of fuel and expand into a red giant. But then there are the true monsters of the cosmos, stars dozens, even hundreds of times larger than the Sun. These giants live fast and die young. Instead of peacefully expanding into red giants, they end their lives in some of the most violent ways possible. When a massive star reaches the end of its life, it can no longer sustain nuclear fusion in its core. Fusion is what keeps a star stable. It's the process of smashing atoms together to create energy. But once a star burns through all its fuel, gravity takes over, and the core starts collapsing in on itself. In a normal supernova, this collapse leads to an explosion so bright that it can be seen across the universe. But in the case of a hypernova, something even more extreme happens. The star isn't just big, it's massive enough that when it collapses, it does so with so much force that it doesn't just explode outward. It also sends out incredibly powerful jets of energy, creating some of the most energetic events we've ever observed. One of the most famous hypernova candidates ever detected was SN 1998 BW. It was linked to a gamma-ray burst, an insanely powerful flash of energy that astronomers believe comes from the formation of a black hole, or a highly magnetized neutron star. This connection between hypernovae and gamma-ray bursts is what makes them even more fascinating. A normal supernova can outshine a galaxy for a short time, but a hypernova, especially one that produces a gamma-ray burst, releases even more energy, sometimes in just seconds. But hypernovae aren't just about destruction. They play a crucial role in shaping the universe as we know it. When these massive explosions happen, they don't just destroy, they create. The extreme temperatures and pressures inside these explosions forge some of the heaviest elements in existence, like gold and platinum. Every piece of gold you've ever seen, every bit of platinum in jewelry or electronics, it all came from massive stellar explosions like these, billions of years ago. Without hypernovae and other violent cosmic events, the universe wouldn't have the heavy elements needed for planets, life, and even our own bodies. But could there be something even more powerful than a hypernova? What about events that make even these cosmic explosions look small by comparison? Some scientists believe that there might be something even rarer and more extreme, quasars. These are massive stars that collapse directly into black holes, releasing incredible amounts of energy in the process. Unlike normal hypernovae, which still leave behind a neutron star or black hole, a quasar might produce energy in a way that's even harder to detect. There's also the possibility of Panspermia supernovae, a rare type of explosion that occurs in extremely massive stars, ones more than 100 times the mass of the Sun. In these cases, the explosion is so powerful that the entire star is obliterated, leaving nothing behind. No black hole, no neutron star, just an expanding cloud of gas and heavy elements spreading through space. Scientists have only found a few possible candidates for these events, but if they exist, they could be some of the most powerful explosions in the universe. But what about explosions even beyond individual stars? Could entire galaxies experience violent bursts of energy on a scale beyond even hypernovae? That's where quasars and blazars come in. These are the most energetic objects in the known universe, powered by supermassive black holes at the centers of galaxies. Unlike a hypernova, which is a one-time event, quasars and blazars can release massive amounts of energy for millions of years. Some of them are so bright that they outshine entire galaxies, despite being billions of light-years away. The idea of these massive cosmic explosions isn't just fascinating, it's also a reminder of how small we are in the grand scale of the universe. If a hypernova were to go off in our galaxy, even from thousands of light-years away, the radiation could have serious effects on Earth's atmosphere. Some scientists even speculate that past gamma-ray bursts might have caused mass extinctions on Earth. If one were to happen close enough, it could strip away our planet's ozone layer, exposing life to deadly cosmic radiation. But for now, most of these explosions are happening safely in the distant universe, giving astronomers a chance to study them and uncover more of their secrets. With telescopes like the James Webb Space Telescope and future observatories, we're constantly discovering new things about these incredible events. The more we learn, the more we realize just how much is still unknown. What other types of cosmic explosions might be out there? Could there be something even more powerful that we haven't detected yet? The universe is full of mysteries, and hypernovae are just one piece of a much larger puzzle. And speaking of cosmic mysteries, what happens when the energy from these explosions interacts with the fabric of space itself? Could they trigger gravitational waves? What about the possibility of them being linked to dark matter or other unknown forces? There's so much more to explore, and the deeper we go, the more mind-blowing the discoveries become. The immense power of hypernovae isn't just a spectacle, it's a force that reshapes the cosmos. These explosions don't just send shockwaves through space. They alter the very structure of galaxies, influence the formation of new stars, and even play a role in the existence of life itself. The remnants of hypernovae, filled with heavy elements, become part of the interstellar medium, the vast clouds of gas and dust that will eventually collapse to form new stars, planets, and possibly even life. In a way, hypernovae are both the engines of destruction and the architects of creation, ensuring that the universe remains in a constant cycle of death and rebirth. But let's dive deeper into what happens during these colossal explosions. When a hypernova occurs, the star's core collapses at an incredible speed. The outer layers are ejected outward in a massive explosion, while the core, under immense pressure, can either collapse into a black hole or an extremely dense neutron star. But unlike normal supernovae, hypernovae generate intense relativistic jets, beams of energy moving at nearly the speed of light. These jets release bursts of gamma radiation, among the most energetic forms of radiation in the universe. This is why hypernovae are often linked to long-duration gamma-ray bursts, GRBs, which can last from a few seconds to several minutes, releasing more energy in that short time than our Sun will emit in its entire lifetime. These gamma-ray bursts are one of the biggest mysteries in astrophysics. We've detected hundreds of them, but we still don't fully understand why they happen. Some scientists believe that the energy from a collapsing hypernova forms a black hole, and as matter falls into it, it creates powerful jets that shoot outward. These jets, when aligned with Earth, appear as intense gamma-ray bursts. But not all hypernovae create these bursts, and not all gamma-ray bursts come from hypernovae. Could there be another unknown mechanism at play? To make things even more complicated, some of these explosions defy expectations. For example, some supernovae have been observed without any accompanying gamma-ray bursts, even when they were massive enough to be hypernovae. This suggests that the direction and formation of the relativistic jets might be more unpredictable than we currently understand. Some hypernovae might produce jets that never make it out of the star's collapsing envelope, trapping the energy within and preventing us from seeing the gamma-ray burst. This means that there could be many more hypernovae occurring throughout the universe that we simply aren't detecting. But what about the long-term effects of these explosions? Hypernovae don't just release energy. They send shockwaves rippling through space, compressing gas clouds and triggering the birth of new stars. In this way, the death of one massive star can lead to the creation of many more. These shockwaves also distribute heavy elements, enriching the interstellar medium with materials that will eventually form planets, moons, and even the building blocks of life. Every atom of iron in your blood, every bit of calcium in your bones, and even the gold in your jewelry, these elements were forged in the heart of a dying star and scattered across space by massive explosions like hypernovae. And while we've observed hypernovae in distant galaxies, could one happen in our own Milky Way? The answer is yes. In fact, it's likely that hypernovae have occurred in our galaxy many times throughout history. The problem is that space is vast, and light from these explosions takes thousands, or even millions, of years to reach us. The last confirmed supernova in the Milky Way was SN 1604, also known as Kepler's supernova, which was visible to the naked eye over 400 years ago. But hypernovae are much rarer. If a hypernova were to go off in our galaxy, and if its gamma ray burst were pointed in our direction, the results could be catastrophic. The intense radiation could strip away Earth's ozone layer, exposing the planet to deadly cosmic rays. Some scientists even theorize that past mass extinctions on Earth could have been triggered by gamma ray bursts from nearby hypernovae. But before you start worrying about a hypernova wiping out life on Earth, it's important to note that such an event would have to be extremely close, within a few thousand light years, to have a significant impact. The nearest massive stars that could go hypernova, like Eta Carinae, are far enough away that they wouldn't pose a direct threat. However, studying these stars is crucial because they give us insight into what might happen when the next hypernova inevitably occurs. One of the biggest challenges in understanding hypernovae is predicting when they will happen. Unlike regular stars, which go through predictable phases of life, massive stars don't always give clear warning signs before they explode. Some show signs of instability, with massive eruptions and fluctuations in brightness, while others seem to go supernova, or hypernova, without much warning at all. Astronomers use powerful telescopes to monitor massive stars, hoping to catch one in the final moments before detonation, but so far, we've never observed the exact moment a star goes hypernova. And here's another mind-bending question: could a hypernova be artificially triggered? Some theories suggest that if a sufficiently advanced civilization had the technology, they could manipulate a massive star's core or artificially induce a collapse. This idea, while purely speculative, opens up fascinating possibilities. Could there be civilizations out there using hypernovae as a source of energy, or even as a weapon? It sounds like science fiction, but the idea isn't entirely impossible. Now, let's push the boundaries even further. What if hypernovae aren't the biggest cosmic explosions? What if there's something even more extreme? Some astronomers speculate that extremely massive stars in the early universe could have undergone explosions far beyond what we see today. These primordial stars, made almost entirely of hydrogen and helium, might have ended their lives in explosions that make modern hypernovae look small by comparison. And then there's the possibility of magnetar hypernovae, explosions involving stars with the most intense magnetic fields in the universe. Magnetars are neutron stars with magnetic fields trillions of times stronger than Earth's, and if one were to undergo a hypernova-like explosion, the energy output could be even more extreme than anything we've observed so far. Some scientists believe that certain gamma-ray bursts might come from these magnetar-driven explosions, adding yet another layer of mystery to the already complex world of hypernovae. But let's step back and consider something truly mind-blowing. What if hypernovae could influence dark matter? Dark matter makes up most of the universe's mass, but we still don't know what it is. Some theories suggest that the immense energy released by hypernovae could interact with dark matter in ways we don't yet understand. Could these explosions be the key to unlocking one of the biggest mysteries in physics? Every time we think we have a grasp on the universe, something new emerges, challenging our understanding and forcing us to ask even bigger questions. Hypernovae are just one piece of the cosmic puzzle, but they're a crucial one. They connect the life and death of stars, the formation of planets, the creation of elements, and even the structure of galaxies. And yet there's still so much we don't know. With future telescopes and advanced simulations, we may one day witness a hypernova in real time, unlocking secrets that have remained hidden for billions of years. But until then, the mystery remains. How many hypernovae are happening in the universe right now? Could there be an explosion even larger than a hypernova waiting to be discovered? And what other secrets are hidden in the aftermath of these incredible cosmic events? The mysteries of hypernovae go beyond just their explosive power. They challenge our understanding of physics itself. The sheer energy output of a hypernova pushes the limits of what we know about nuclear fusion, gravity, and even relativity. When a star collapses into a black hole during a hypernova, the core undergoes a process so violent that spacetime itself is twisted and warped beyond recognition. Some scientists speculate that these extreme conditions could even create miniature wormholes or distortions in the fabric of reality. Could hypernovae hold the key to understanding the fundamental nature of the universe? One of the strangest aspects of hypernovae is their role in creating exotic forms of matter. The extreme pressure inside a collapsing hypernova core forces atoms to merge in ways that don't happen anywhere else in the universe. This can lead to the formation of neutron stars, which are so dense that a teaspoon of their material would weigh billions of tons. But there's an even weirder possibility: quark stars. Some physicists believe that under even greater pressure, neutrons themselves could break apart, leaving behind a sea of free quarks, the fundamental building blocks of matter. If these quark stars exist, they would be unlike anything we've ever seen, and their existence could change our understanding of particle physics. And then there's the question of antimatter. Hypernovae produce an enormous amount of high-energy radiation, which in theory could lead to the creation of antimatter. Antimatter is the mirror opposite of regular matter. When it comes into contact with normal particles, the two annihilate each other in a burst of pure energy. Some researchers speculate that hypernovae could be one of the few places in the universe where antimatter is created in significant amounts. Could this be a clue in solving the mystery of why our universe is made mostly of matter and not equal parts matter and antimatter? But hypernovae don't just exist in isolation. They are part of a much bigger cosmic cycle. Their explosions send shockwaves that travel for thousands of light years, compressing interstellar gas and triggering the formation of new stars. This means that hypernovae don't just destroy, they create. Without them, the elements necessary for planets and life wouldn't exist. The oxygen we breathe, the calcium in our bones, the iron in our blood, none of these could have formed without the violent deaths of ancient massive stars. In a way, hypernovae are the ultimate paradox. They bring destruction, but they also bring life. But what happens in the moments before a hypernova erupts? Astronomers have been trying to catch a star in the act of going hypernova, but it's incredibly difficult. Some stars show warning signs: massive eruptions of gas, sudden changes in brightness, or strange pulses of radiation. Others explode with almost no warning at all. Scientists are now using artificial intelligence to scan the skies, searching for the faint clues that might tell us when a star is about to go hypernova. If we could predict these explosions, we could finally witness one in real time, gathering data that could unlock some of the biggest mysteries of astrophysics. And here's another strange question: could hypernovae explain some of the biggest mysteries of the universe, like fast radio bursts? Fast radio bursts, FRBs, are one of the weirdest phenomena in astronomy. Short, intense bursts of radio waves that last only milliseconds but release as much energy as the sun does in a year. Some scientists suspect that FRBs might be linked to hypernovae, possibly from magnetars, neutron stars with magnetic fields so strong they could tear atoms apart. If a hypernova creates a magnetar, it's possible that the intense energy of the explosion could trigger these strange bursts of radio waves. But hypernovae may also be connected to something even more mysterious: dark energy. Dark energy is the force driving the accelerating expansion of the universe, but we still don't know what it is. Some researchers have proposed that extreme cosmic events like hypernovae could play a role in its behavior. Could the violent release of energy in a hypernova have effects that ripple across space-time, influencing the large-scale structure of the cosmos? And then there's the possibility that hypernovae might not be as rare as we think. Because they release so much energy, hypernovae can outshine entire galaxies for a brief period of time. This makes them easy to spot in distant parts of the universe. But what if there are smaller-scale hypernovae, events that don't quite reach the same energy levels but are still far more powerful than regular supernovae. If these exist, they might be going unnoticed simply because they don't produce the telltale gamma-ray bursts we usually associate with hypernovae. This raises another question: could hypernovae be different in other galaxies? Most of what we know about them comes from observations of relatively nearby galaxies, but the universe is vast, and the conditions in other regions of space could be wildly different. Some galaxies have far more massive stars than our own, which means they might experience even larger and more frequent hypernovae. Other galaxies have strange environments, like supermassive black holes at their centers or extreme magnetic fields, which could alter the way these explosions happen. And what about rogue hypernovae? Most stars are bound to galaxies, but some get ejected into intergalactic space, either through gravitational interactions or as part of binary systems where one star explodes and slingshots the other away. If a massive star were floating alone in deep space, far from any galaxy, and it went hypernova, what would happen? Without surrounding gas and dust to absorb and scatter the explosion's energy, the hypernova might behave in ways we've never seen before, releasing almost all of its energy as pure radiation instead of a visible explosion. Hypernovae also have a role in one of the strangest ideas in physics, the concept of cosmic censorship. According to general relativity, singularities, places where gravity becomes infinite, are hidden inside black holes, shielded from the outside universe. But some physicists wonder if a hypernova could ever create a naked singularity, an exposed point of infinite gravity that isn't hidden inside a black hole. If such an event were possible, it would break our current understanding of spacetime and force us to completely rethink the laws of physics. And then there's the ultimate question: could hypernovae have played a role in the origins of life? We usually think of explosions as destructive, but hypernovae spread the building blocks of life across the cosmos. Some researchers even suggest that cosmic rays from hypernovae could have influenced early DNA formation on Earth, possibly even triggering mutations that led to the evolution of complex life. Could life itself owe its existence to these massive explosions? There are so many questions left unanswered. What happens in the exact moment a hypernova's core collapses? Could a hypernova ever be strong enough to trigger another event we've never seen before? Are there even more powerful explosions in the universe waiting to be discovered? We are only scratching the surface of what we know, and as telescopes and technology improve, we will likely uncover even deeper mysteries. One thing is certain: hypernovae are among the most powerful and mysterious events in the cosmos. They shape galaxies, create the elements of life, and push the boundaries of what we understand about physics. But they also remind us of how much we still don't know. Every hypernova that we observe is a window into a universe far more complex and strange than we ever imagined. And with each new discovery, we get one step closer to unlocking the deepest secrets of the cosmos. Hypernovae are more than just explosions. They are cosmic engines, reshaping the universe in ways we're only beginning to understand. One of the most intriguing mysteries surrounding these events is their connection to the formation of black holes. When a hypernova occurs, the core of the dying star collapses so violently that it crushes matter into an infinitely dense point, a singularity. This is the birth of a black hole, an object so powerful that not even light can escape its gravitational pull. But there's a question that has puzzled scientists for years. Does every hypernova create a black hole, or could some result in something even stranger? There's a possibility that, under the right conditions, a collapsing hypernova might not form a traditional black hole but instead an object known as a gravastar. A gravastar is a hypothetical alternative to black holes, proposed as a way to avoid the paradoxes associated with singularities. Instead of collapsing into an infinitely dense point, a gravastar would form a shell of ultra-dense matter with a core made of dark energy. If these objects exist, they would appear almost identical to black holes from the outside, but inside, they would obey completely different laws of physics. Could hypernovae be the missing piece in proving whether gravastars are real? Another strange possibility is that hypernovae might create objects even more extreme than regular black holes, primordial black holes. Unlike the supermassive black holes at the centers of galaxies, which grow over billions of years, primordial black holes are thought to have formed in the earliest moments of the universe. Some theories suggest that the incredible energy of a hypernova might be able to trigger the formation of a primordial black hole in modern times, essentially recreating the conditions of the Big Bang inside a collapsing star. If this were true, it would be one of the most groundbreaking discoveries in physics. But hypernovae don't just create black holes, they may also play a role in shaping entire galaxies. When a hypernova explodes, it sends shockwaves through space that can trigger bursts of star formation. In some cases, these shockwaves can travel for hundreds or even thousands of light years, compressing gas clouds and igniting the birth of new stars. This means that the death of one massive star could lead to the creation of many more, fueling the endless cycle of cosmic evolution. Some astronomers even suspect that hypernovae could be responsible for shaping the structure of galaxies, sculpting spiral arms and influencing the formation of star clusters. This brings up an even bigger question. Could hypernovae be responsible for some of the biggest cosmic structures we see in the universe? The large-scale structure of the cosmos is made up of vast filaments of galaxies, separated by enormous voids of empty space. Some scientists believe that hypernovae, along with other cosmic explosions, might have played a role in shaping this structure by driving matter outward and influencing the distribution of galaxies. If this is true, then hypernovae aren't just local events, they are part of the grand design of the universe itself. Another mystery surrounding hypernovae is their connection to cosmic rays. Cosmic rays are high-energy particles that travel through space at nearly the speed of light, bombarding Earth constantly. These particles come from some of the most powerful events in the universe, and many scientists believe that hypernovae are one of their main sources. When a hypernova explodes, it accelerates particles to incredible speeds, sending them hurtling across the cosmos. Some of these particles eventually reach Earth, where they can have strange effects on our atmosphere and even on human technology. Could hypernovae be shaping life on our planet in ways we don't yet understand? There's also the question of whether hypernovae could be linked to some of the strangest phenomena in astrophysics: gamma-ray bursts. Gamma-ray bursts, GRBs, are the most powerful flashes of energy ever detected in the universe, capable of releasing more energy in a few seconds than the Sun will in its entire lifetime. Many GRBs are thought to be caused by hypernovae, but not all of them fit this pattern. Some seem to come from events that don't match any known type of explosion, leaving astronomers puzzled. Could there be an even more powerful type of explosion out there, beyond hypernovae? And if hypernovae are responsible for gamma-ray bursts, what does that mean for planets in their path? A sufficiently strong GRB could potentially strip away the atmosphere of a planet, making it uninhabitable. Some scientists have speculated that past mass extinctions on Earth could have been triggered by distant gamma-ray bursts. If a hypernova occurred close enough to our solar system, could it wipe out life as we know it? This brings us to one of the most unsettling possibilities. What if a hypernova happened nearby? Thankfully, there are no stars close enough to Earth that are likely to go hypernova in the near future. But in cosmic terms, near could mean thousands of light years away. If a hypernova were to explode within a few thousand light years of Earth, the radiation it emitted could have serious consequences for our planet. The intense gamma rays could damage the ozone layer, increasing harmful radiation from the Sun and potentially causing widespread environmental changes. Could past hypernovae have played a role in shaping Earth's history without us realizing it? But hypernovae aren't just destructive, they may also be the key to solving some of the biggest mysteries of the universe. One of the strangest ideas in modern physics is the possibility that our universe is just one of many, a part of a vast multiverse. Some theories suggest that the extreme energy of a hypernova could, under the right conditions, create a bridge between different universes, forming what's known as a white hole. A white hole is essentially the opposite of a black hole. While black holes pull everything in, white holes push everything out. Could hypernovae be creating gateways to other realities? And then there's the idea that hypernovae might be influencing the nature of dark matter. Dark matter makes up most of the mass in the universe, yet we still don't know what it is. Some researchers believe that the conditions inside a hypernova might be capable of producing exotic particles that interact with dark matter. If we could understand how hypernovae affect dark matter, we might finally unlock one of the greatest mysteries in astrophysics. There's also the possibility that hypernovae might be connected to time itself. Some extreme theories suggest that the warping of spacetime caused by a collapsing star might, under the right conditions, create tiny loops in time, closed time-like curves. If such a thing were possible, it would mean that hypernovae could be linked to time travel in ways we don't yet understand. The deeper we look into hypernovae, the more questions we uncover. Are there types of hypernovae we haven't discovered yet? Could hypernovae be triggering unknown cosmic events? Are there hypernovae happening right now that we can't detect because they occur in parts of the universe we have yet to explore? The mysteries surrounding these colossal explosions are far from solved, and every new discovery brings us closer to unraveling the true nature of the cosmos. If hypernovae have the power to shape galaxies, create black holes, and even influence cosmic structures, then there's another question we have to ask. Could they be responsible for some of the biggest anomalies in the universe? One of the strangest cosmic mysteries is the existence of ultraluminous supernovae, explosions so bright and powerful that they defy everything we know about stellar death. Some of these explosions shine hundreds of times brighter than a normal supernova, and their exact cause remains unknown. Could they be an even more extreme version of hypernovae? One possibility is that these ultraluminous explosions are caused by something called a Panspermia supernova. Unlike regular supernovae or hypernovae, which occur when a star collapses under its own gravity, a Panspermia supernova happens when a star is so massive that it begins producing antimatter in its core. When this happens, the entire star is blown apart in one massive detonation, leaving nothing behind, not even a black hole. These explosions could be responsible for some of the brightest events in the universe, but they still don't fully explain the energy levels seen in ultraluminous supernovae. Another theory is that ultraluminous supernovae are powered by Magnetars, neutron stars with magnetic fields trillions of times stronger than Earth's. If a hypernova leaves behind a rapidly spinning magnetar, the intense magnetic fields could generate an enormous amount of energy, making the explosion far more powerful than usual. But there's a problem with this idea. We don't always see evidence of a magnetar after these explosions occur. So what else could be causing these extreme cosmic blasts? Some astronomers believe that the answer might lie in something even more exotic: quark stars. A quark star is a hypothetical type of star that forms when a collapsing neutron star becomes so dense that the neutrons themselves break down into their fundamental building blocks, quarks. These objects would be even denser than neutron stars, but not quite as extreme as black holes. If quark stars exist, they could play a role in some of the most powerful explosions in the universe. Could a hypernova be the missing link that explains how these strange objects form? And then there's the possibility that hypernovae could be linked to one of the most baffling cosmic phenomena: fast radio bursts, FRBs. FRBs are incredibly short but powerful bursts of radio waves that come from deep space, lasting only a few milliseconds but releasing as much energy as the sun emits in a year. Some FRBs repeat, while others appear to be one-time events, making them even more mysterious. While some scientists suspect that magnetars are behind these bursts, others have proposed that hypernovae could be playing a role. Could the collapse of a massive star produce an intense radio signal in its final moments? If so, we might be witnessing the direct aftermath of a hypernova every time we detect an FRB. This also raises another fascinating question: could hypernovae be sending signals across the universe? Some researchers have speculated that if an advanced alien civilization wanted to communicate over vast distances, they might use the power of cosmic explosions to amplify their signals. By harnessing the energy of a hypernova, a civilization could potentially send messages across entire galaxies. If we ever detect an unusual pattern in the radiation from a hypernova, could it be evidence of an extraterrestrial intelligence trying to get our attention? And speaking of extraterrestrials, could hypernovae play a role in spreading life across the cosmos? There's a theory known as Panspermia, which suggests that life could be transported between planets and even star systems by asteroid impacts. If a hypernova occurs near a planetary system, it could blast debris, including potentially life-bearing material, out into space at incredible speeds. Some of this debris could travel for millions or even billions of years before crashing onto another planet, possibly seeding it with the building blocks of life. If this idea is correct, hypernovae might not just be engines of destruction, they could also be catalysts for life. But if hypernovae are so powerful, is it possible that one could ever occur in our own galaxy? The answer is yes, and it may have already happened. There is evidence to suggest that hypernovae have occurred in the Milky Way in the past, leaving behind unusual remnants that don't fit the pattern of a regular supernova. Some scientists believe that a hypernova explosion may have been responsible for the formation of certain elements in our solar system, contributing to the very materials that make up Earth itself. If that's true, then we are, in a sense, the product of a hypernova that exploded billions of years ago. And if a hypernova were to occur in the Milky Way today, what would happen? Thankfully, most candidate stars for a hypernova are located far enough away that they wouldn't pose a direct threat to Earth. However, if one were to explode within a few thousand light years of us, the resulting radiation could have significant effects on our planet. In the worst-case scenario, a gamma-ray burst from a nearby hypernova could strip away our atmosphere, exposing Earth's surface to deadly cosmic radiation. While this is unlikely, it's not impossible. There is even speculation that past mass extinctions may have been triggered by similar cosmic events. And then there's the ultimate question: could hypernovae be responsible for some of the deepest mysteries of physics itself? Some physicists have suggested that the extreme conditions inside a hypernova could create exotic particles that we have never observed before. These particles could help explain dark matter, the mysterious substance that makes up most of the universe's mass but remains invisible to our instruments. If hypernovae are producing dark matter particles, then every explosion could be reshaping the universe in ways we don't yet understand. There's even the possibility that hypernovae could be influencing the fundamental nature of reality itself. Some theories suggest that certain types of cosmic explosions might be capable of altering the fabric of spacetime, creating ripples that could propagate across the universe. If this is true, then hypernovae could be acting as cosmic reset buttons, reshaping the universe on the largest scales. Could these events be linked to the mysterious expansion of the universe, or even to the nature of time itself? The deeper we look, the more we realize that hypernovae are not just explosions. They are keys to understanding some of the biggest questions in science. They may hold the secrets to black holes, dark matter, the origins of life, and even the possibility of other universes. And yet there is still so much we don't know. Every new discovery leads to more questions, and the more we learn, the more we realize just how little we truly understand about the cosmos. What we do know is that hypernovae are among the most powerful forces in the universe, shaping galaxies, forging elements, and perhaps even influencing the course of life itself. As we continue to study these cosmic titans, we may one day unlock answers that change everything we thought we knew about the universe. But for now, one thing is certain: hypernovae are not just explosions. They are windows into the very nature of existence itself. But as much as we understand about hypernovae, the truth is that we are only scratching the surface. If these cosmic events are capable of influencing galaxies, creating black holes, and possibly even triggering new forms of matter, then we have to ask, what else might they be doing that we haven't even considered? Could hypernovae be responsible for some of the most baffling astrophysical phenomena that scientists still struggle to explain? One of the strangest concepts in modern astrophysics is the idea of dark energy, the mysterious force that is causing the universe to expand at an accelerating rate. Right now, we have no definitive explanation for why the universe isn't just expanding, but actually speeding up as it does. Some scientists have theorized that hypernovae, or more specifically, the gamma-ray bursts they produce, could play a role in this. These bursts release vast amounts of energy, and if they interact with spacetime in a certain way, they might be contributing to the acceleration of cosmic expansion. While this is still a highly speculative idea, it raises an intriguing possibility. Are hypernovae not just destroying stars, but actively shaping the evolution of the universe itself? And if hypernovae have such a dramatic influence on space, could they be tied to one of the most haunting questions in physics? Why does time move forward? According to what we understand about the laws of physics, time should be reversible on the quantum level. Yet, in reality, we experience time moving in only one direction, forward. Some researchers believe that extreme astrophysical events like hypernovae could be generating the conditions that make time appear to have a direction. If true, that would mean these cosmic explosions are not just shaping matter and space, but even the flow of time as we experience it. And what about the possibility that hypernovae could be influencing the structure of the universe on an even larger scale? If they are capable of producing powerful waves in spacetime, could they also be responsible for some of the unexplained anomalies we've detected in the cosmic microwave background radiation, the faint afterglow of the Big Bang? There are certain large-scale structures in the universe, like the cold spot and the cosmic background radiation, that defy standard cosmological models. Some scientists have proposed that these anomalies could be the remnants of past hypernovae so massive that they left their imprint on the very fabric of space itself. But perhaps the most mind-bending idea is that hypernovae might not just be cosmic explosions, but cosmic portals. Some fringe theories suggest that the immense gravitational and energetic forces at play during a hypernova could tear open the fabric of reality, creating connections between different points in space, or even different universes. Could hypernovae be acting as natural gateways to other dimensions? While there is no solid evidence to support this idea, the fact remains that we don't fully understand what happens at the singularity of a collapsing hypernova. If a hypernova creates a black hole, and that black hole becomes a wormhole, then could it be possible that hypernovae are scattering energy and matter into entirely different regions of space-time? If that's true, then hypernovae might not just be events that end stars. They might be events that give birth to entirely new cosmic structures. Some physicists believe that black holes could act as seeds for new universes, meaning that each time a hypernova occurs and collapses into a singularity, it could be creating a new universe somewhere else in the multiverse. If that's the case, then hypernovae aren't just explosions. They could be part of an infinite cycle of creation and destruction, shaping the very nature of existence itself. And then we have to wonder, are we witnessing hypernovae in other galaxies that are, in a way, watching the birth of their own separate realities? Could there be some kind of cosmic network, an unseen web connecting these cataclysmic events across vast distances? If hypernovae are responsible for shaping the fundamental structure of the cosmos, then what does that mean for our understanding of reality? Could hypernovae be the missing key to unifying everything we know about physics, from relativity to quantum mechanics to the structure of the multiverse? The more we study hypernovae, the more questions emerge. Every explosion is a message from the past, a glimpse into a process that might be far more significant than we ever imagined. Hypernovae are not just rare cosmic events, they may be telling us something profound about the nature of reality. And as we continue searching the skies, we may one day discover that these seemingly chaotic explosions are actually part of an intricate and interconnected system, one that holds the answers to the greatest mysteries of the universe. The idea that hypernovae could be shaping the very structure of reality is one of the most fascinating possibilities in astrophysics. But to truly understand the impact of these cosmic explosions, we have to consider what happens in the moments after they occur. When a hypernova detonates, it doesn't just release unimaginable amounts of energy, it also sends shockwaves through space, leaving a permanent mark on its surroundings. One of the biggest mysteries surrounding hypernovae is their relationship with black holes. We know that many hypernovae lead to the formation of stellar mass black holes, but there's a lot we still don't understand about what happens in the final moments before collapse. Some scientists believe that during a hypernova explosion, an event horizon forms around the dying star's core before the full collapse is complete. This means that some of the energy and material from the explosion might be trapped in a kind of limbo, either fully ejected into space nor completely absorbed into the forming black hole. This strange in-between state could explain some of the anomalies we observe in hypernova remnants. There are cases where astronomers detect powerful gamma-ray bursts that last much longer than they should, or where energy seems to be coming from a source that should no longer exist. Could this be the result of energy temporarily trapped in a black hole's event horizon before being released in ways we don't yet understand? If so, it would mean that hypernovae are not just massive explosions but are also playing a role in shaping the very nature of black holes themselves. Another mystery is the possibility that hypernovae could be responsible for some of the strangest objects in the universe, magnetars. A magnetar is a type of neutron star with a magnetic field so strong that it defies comprehension. These objects can generate magnetic fields trillions of times stronger than Earth's, and they emit bursts of energy that can be detected across the galaxy. Some scientists believe that hypernovae could be the birthplace of magnetars, with certain conditions during the explosion leading to the formation of these ultra-dense, highly magnetized remnants. But if hypernovae can create magnetars, does that mean they could also be responsible for even stranger objects, ones that we haven't yet discovered? Some theories suggest that hypernovae might be capable of creating exotic forms of matter. We know that the extreme conditions inside a collapsing star can force particles together in ways that don't occur anywhere else in the universe. Some physicists have speculated that hypernovae might be creating Quark stars, objects where the immense pressure has broken down normal atomic structures, leaving behind only a soup of fundamental particles known as quarks. If Quark stars exist, they could be a completely new state of matter, one that challenges everything we know about physics. And if hypernovae can create entirely new forms of matter, could they also be producing unknown particles? Some scientists believe that these explosions could be generating exotic particles that don't fit into our current understanding of physics. Particles that might help explain dark matter, the mysterious substance that makes up most of the mass in the universe but has never been directly observed. Could hypernovae be factories for the missing components of the cosmos? If so, it would mean that every hypernova is a kind of experiment, creating and dispersing unknown materials across the universe, shaping galaxies in ways we still don't fully understand. But perhaps the biggest question is, could hypernovae affect life itself? We know that supernovae have the potential to be dangerous, with their radiation capable of wiping out planets within a certain range. But hypernovae are on an entirely different scale. If one were to occur close enough to Earth, it could have devastating consequences for our planet's atmosphere, stripping away layers of protection and exposing life to deadly radiation. Some researchers have even suggested that past mass extinctions on Earth could have been triggered by hypernovae in our cosmic neighborhood. But beyond destruction, could hypernovae also play a role in creating the conditions necessary for life? We know that these explosions scatter heavy elements across the universe, seeding new star systems with the ingredients needed to form planets and, potentially, living organisms. If hypernovae are responsible for distributing the building blocks of life, then it's possible that we owe our very existence to these violent cosmic events. And if hypernovae are influencing the formation of life, could they be connected to one of the greatest mysteries of all, why life exists in the universe in the first place? Some scientists have speculated that the distribution of elements created by hypernovae might not be random, but part of a larger pattern, one that guides the formation of habitable planets. Could it be that hypernovae are not just accidents of nature, but part of a process that ensures the emergence of life across the cosmos? If so, then we have to reconsider everything we thought we knew about the universe. Hypernovae might not just be cataclysmic events, they could be the architects of reality itself, shaping space, time, matter, and even life in ways we are only beginning to understand. Every explosion is a message from the past, a glimpse into the fundamental forces that drive the cosmos. And as we continue to study these extraordinary events, we may one day unlock the secrets of the universe itself. Hypernovae could be the missing link in understanding the universe's deepest mysteries, but they also raise even more questions. If they are responsible for spreading the elements that form planets and possibly life, could there be an even greater connection between these massive cosmic explosions and the development of intelligent civilizations? If hypernovae shape galaxies and determine where stars form, could they also dictate where life has the best chances of evolving? One of the biggest questions in astrophysics is why life exists on Earth but seems so rare elsewhere. Could hypernovae be influencing the distribution of life-supporting elements in ways we don't yet understand? If these explosions happen more frequently in certain regions of the universe, could they create cosmic hot spots where the conditions for life are more favorable? If so, That could mean entire clusters of galaxies have a higher probability of hosting habitable worlds, while other areas remain barren due to the lack of heavy element distribution. But this raises another question. If hypernovae shape the fabric of the cosmos, do they also determine the fate of civilizations? We often think of cosmic disasters as random, but what if hypernovae act as a kind of natural selection mechanism on a universal scale? If a civilization develops too close to a hypernova-prone region, could it be wiped out before ever reaching the point of interstellar travel? Could that explain why we haven't found intelligent life? Because hypernovae continuously reset the clock on advanced societies before they have a chance to explore the galaxy? And what about the long-term effects of hypernovae? These explosions don't just vanish after they occur. They leave behind some of the most extreme objects in the universe, like black holes, neutron stars, and pulsars. Some scientists believe that hypernovae could even create wandering rogue black holes, dark objects that move unpredictably through space, consuming anything in their path. If hypernovae are scattering black holes across the cosmos, could there be one moving through our galaxy right now, undetected, with the potential to disrupt planetary systems? There's also the question of whether hypernovae could influence the fundamental structure of spacetime itself. Some theories suggest that the most powerful cosmic events, like hypernovae, might have the ability to create tiny tears in the fabric of reality. These distortions, sometimes referred to as topological defects, could behave like cosmic scars left behind from the most violent explosions in the universe. If hypernovae can generate these space-time anomalies, they could be responsible for some of the unexplained phenomena we observe in deep space, such as the strange warping of light from distant galaxies. But if hypernovae can warp space, could they also have an effect on time? Some physicists have speculated that the energy released in a hypernova could be enough to trigger local distortions in the flow of time itself. While this idea remains purely theoretical, it suggests that hypernovae could create regions of space where time moves at a different rate compared to the rest of the universe. Could it be possible that hypernovae explosions leave behind echoes, remnants of time trapped within the expanding shockwave? If so, could we one day find evidence of past cosmic explosions still playing out in a different time frame than our own? And then there's the biggest mystery of all. Could hypernovae hold the key to understanding dark energy? Dark energy is the force that is driving the expansion of the universe, and we currently have no idea what it is or where it comes from. But some scientists have suggested that extreme cosmic events, like hypernovae, might be connected to dark energy in ways we haven't yet realized. If hypernovae are capable of releasing unknown particles or influencing the fundamental structure of space, could they also be contributing to the mysterious force that is accelerating the expansion of the universe? This idea leads to an even more mind-bending possibility. Could hypernovae be influencing the ultimate fate of the cosmos? If these explosions are connected to dark energy, then their role in the universe might be far greater than we ever imagined. They might not just be shaping individual galaxies. They could be playing a part in the large-scale evolution of the universe itself. If hypernovae are tied to the forces that govern the expansion of space, could they be responsible for triggering shifts in the way the universe itself behaves? Some theories suggest that the universe might go through cycles of expansion and contraction, with certain cosmic events acting as catalysts for these shifts. If hypernovae are somehow linked to this process, then they might be more than just violent explosions. They might be fundamental drivers of cosmic evolution. And if hypernovae are influencing the expansion of the universe, could they also be connected to the possibility of a multiverse? Some scientists believe that the energy released in the most powerful cosmic explosions could be enough to disrupt the very fabric of reality, potentially creating pockets of space that exist outside of our known universe. Could hypernovae be creating bridges between different regions of the multiverse, or even birthing entirely new universes? If that's the case, then hypernovae might not just be events within our universe. They might be part of a much larger, more complex system of cosmic creation. Every hypernova could be an explosion not just in space, but in the structure of reality itself, sending ripples across the boundaries of existence. If this is true, then studying hypernovae might not just tell us about the fate of stars. It could reveal the fundamental nature of reality itself. Hypernovae might be more than just the universe's most powerful explosions. They could be cosmic architects, shaping reality in ways we are only beginning to grasp. If they are capable of producing black holes, neutron stars, and even influencing dark energy, then their role in the universe extends far beyond just destruction. They might be essential in creating the conditions that allow galaxies, planets, and even life to exist. But what if their influence goes even deeper? Could hypernovae be the hidden hand behind some of the universe's most puzzling mysteries? One of the most perplexing questions in astrophysics is the distribution of matter in the universe. When we look at large-scale cosmic structures, we see an intricate web of galaxies connected by vast filaments of gas and dark matter. But why does matter arrange itself in these specific patterns? Some scientists have suggested that hypernovae could play a role in shaping these cosmic structures. The energy released in a hypernova could send shockwaves rippling through intergalactic space, influencing the formation of these massive cosmic filaments. If this is true, then hypernovae might be responsible for the very framework of the universe as we see it today. But what about the missing matter in the universe? When we measure the total mass of galaxies, we find that there isn't enough visible matter to explain their gravitational behavior. This has led scientists to propose the existence of dark matter, a mysterious substance that makes up most of the universe's mass but remains undetectable. However, some researchers believe that hypernovae could be producing exotic particles that might explain at least part of this missing mass. Could it be possible that hypernovae are factories for strange, unknown particles that interact with gravity but remain invisible to our telescopes? If hypernovae are tied to dark matter, then they might hold the key to one of the greatest scientific mysteries of all time. And if they are connected to dark energy as well, then they could be responsible for not just the structure of the universe, but also its ultimate fate. Some scientists believe that the universe will continue expanding forever, gradually growing colder and emptier as galaxies drift apart. Others think that dark energy might one day reverse, leading to a big crunch where the universe collapses back in on itself. But what if hypernovae are influencing this process? Could they be acting as cosmic regulators, determining whether the universe expands indefinitely or eventually contracts? And what if hypernovae have played a role in shaping time itself? We often think of time as a constant, but in reality, it is deeply connected to the fabric of space. If hypernovae are capable of creating extreme distortions in spacetime, then they might also be responsible for subtle shifts in the flow of time on a cosmic scale. Some physicists have speculated that massive cosmic events could generate time ripples, distortions in the way time moves across different regions of the universe. If hypernovae are responsible for creating these ripples, then they could be influencing the passage of time in ways we don't yet understand. This raises a mind-bending possibility. Could hypernovae be the key to understanding time travel? If they are capable of warping spacetime, then it might be possible that some remnants of these explosions could create conditions where time moves differently than in the rest of the universe. Some theories suggest that the intense gravitational fields left behind by a hypernova could act as a natural time machine, allowing objects to move through time at different rates. If this is true, then studying hypernovae could bring us one step closer to unlocking the secrets of time itself. But what about their impact on life? If hypernovae distribute the elements necessary for life, could they also be responsible for triggering evolutionary changes on a cosmic scale? Some scientists have proposed that radiation from hypernovae could have influenced the development of life on Earth by causing mutations in early organisms. If this is true, then hypernovae might not just be responsible for creating the raw materials of life, they might also be shaping the way life evolves. And if hypernovae are connected to the origins of life, then could they also be responsible for its destruction? We know that gamma-ray bursts, which are often associated with hypernovae, have the potential to sterilize entire planets by stripping away their atmospheres. If a hypernova were to occur close enough to Earth, it could have devastating effects on our planet's ability to support life. Could it be possible that hypernovae have already wiped out advanced civilizations elsewhere in the universe? If so, then hypernovae might be one of the reasons why we haven't found extraterrestrial life. The universe is vast, and yet, despite our search for intelligent civilizations, we have found no definitive evidence that we are not alone. Some scientists have proposed the idea of a great filter, a point in the development of intelligent life where most civilizations failed to survive. Could hypernovae be part of this filter? If so, then the very explosions that create the conditions for life might also be responsible for destroying it before it has a chance to reach interstellar travel. But what if hypernovae are more than just cosmic destroyers? What if they are also responsible for seeding life across the universe? Some researchers believe that the elements and organic compounds formed in these explosions could be carried across space on interstellar dust and asteroids. If these materials land on a planet with the right conditions, they could provide the essential ingredients for life to begin. Could it be possible that hypernovae are not just shaping galaxies, but also spreading the seeds of life itself across the cosmos? And if hypernovae can influence the potential for life in the universe, could they also play a role in how civilizations develop? If a planet is located in a region of space with frequent hypernovae, it might face repeated cycles of destruction and renewal, preventing civilizations from reaching a technological level where they can explore the stars. On the other hand, planets in more stable regions might have the time needed for intelligent life to evolve and thrive. If this is true, then hypernovae might be one of the key factors in determining where advanced civilizations can exist. There's also the question of whether hypernovae could be used as a source of energy by advanced civilizations. The amount of energy released in a single hypernova is far beyond anything humanity can currently harness, but a sufficiently advanced species might be able to tap into this power. Could hypernovae serve as natural energy sources for extraterrestrial civilizations? If so, then they might not just be cosmic explosions, they could be a resource that advanced societies rely on for their survival. And what if hypernovae are even more important than we realize? Some scientists believe that the conditions inside a hypernova might be capable of producing unknown particles or even exotic forms of matter that we have never encountered before. If this is true, then studying hypernovae could lead to groundbreaking discoveries in physics, helping us unlock new fundamental forces of nature. Hypernovae might not just be an endpoint in a star's life, they could be the catalysts for some of the universe's most important processes. They might hold the answers to the origins of life, the mysteries of dark matter and dark energy, and even the fundamental nature of time and space. And if they are capable of influencing the fate of civilizations, then understanding hypernovae could be one of the most important scientific pursuits of all time. Hypernovae could be the key to understanding some of the deepest mysteries of the cosmos. But what if their impact goes beyond just science? What if hypernovae have shaped not only the physical universe but also the very way we think about existence itself? Hypernovae challenge our philosophical understanding of the universe. They force us to confront the sheer scale of cosmic events, reminding us of our place in an endlessly vast and powerful cosmos. But they also offer a strange kind of hope. The very explosions that signal the death of a star also create the conditions for new stars, planets, and even life to emerge. But what if hypernovae hold an even greater secret, one that could redefine our understanding of existence itself? Some physicists have speculated that the extreme conditions inside a hypernova might not just create black holes, but could also tear at the very fabric of reality. Could hypernovae be responsible for opening pathways to other dimensions? Some theories suggest that the intense warping of spacetime around these explosions might create what are known as wormholes, hypothetical bridges between different points in space and time. If this is true, then hypernovae might not just shape galaxies, they might create tunnels through the cosmos that could one day be used for interstellar travel. And if hypernovae can produce wormholes, could they also lead to the birth of entirely new universes? Some scientists have proposed that when a black hole forms, it might not just collapse in on itself but could instead bud off a new universe on the other side of the singularity. If this is true, then every hypernova that results in a black hole might be creating an entirely new reality, a separate cosmos with its own laws of physics. Could our own universe have been born from the death of a hypernova in some earlier reality? If this idea is true, then hypernovae might be far more than just cosmic explosions. They might be the mechanisms through which new universes are created. This would mean that the multiverse, a concept long debated in theoretical physics, could be real, with hypernovae acting as cosmic seeds, planting the beginnings of new realities across an infinite expanse of existence. And if hypernovae are tied to the birth of new universes, then they might also be linked to the fundamental forces that shape reality itself. Some scientists believe that inside the core of a hypernova, conditions could be extreme enough to momentarily alter the fundamental forces of nature. Could hypernovae hold the key to unifying the laws of physics? If so, then understanding these explosions might help us unlock the long-sought theory of everything, the ultimate explanation of how the universe works at both the largest and smallest scales. But perhaps the most mind-bending possibility is that hypernovae might be acting as a kind of cosmic intelligence test. If an advanced civilization were to develop the technology to fully understand and harness the energy of a hypernova, they might unlock capabilities far beyond anything we can currently imagine. Could hypernovae be a kind of natural barrier, an obstacle that only the most advanced beings in the universe can overcome? If so, then they might serve as a kind of cosmic gate, separating civilizations that remain bound to their home planets from those capable of mastering the true power of the cosmos. If hypernovae are a kind of test, then what lies beyond? What would happen if we were to one day learn how to manipulate the energy of a hypernova, to bend spacetime as easily as we harness electricity today? Could we use hypernovae to open pathways to distant galaxies, to explore the depths of the universe in ways we never thought possible? Or would tampering with such immense forces unleash consequences beyond our comprehension? These are the kinds of questions that make hypernovae one of the most fascinating mysteries of space. They are not just explosions. They are cosmic events that challenge our understanding of physics, time, and reality itself. They are destroyers and creators, agents of chaos and architects of the cosmos. And as we continue to study them, we may one day unlock secrets that could change the very nature of what it means to be human. Hypernovae might not just be a cosmic phenomenon. They could be the ultimate key to understanding the fate of the universe itself. If these massive explosions can create black holes, generate gamma-ray bursts, and even reshape entire galaxies, then what does that mean for the long-term evolution of the cosmos? Could hypernovae play a role in the ultimate endgame of the universe? One of the most fascinating ideas in modern cosmology is the concept of entropy, the gradual increase of disorder in a system. Over time, as stars burn out and galaxies drift apart, the universe is slowly moving toward a state of maximum entropy, also known as the heat death of the universe. But what if hypernovae are one of the few forces capable of resisting this inevitable decline? Unlike smaller stellar explosions, hypernovae release such an immense amount of energy that they can trigger new waves of star formation. When a hypernova occurs, it doesn't just destroy, it seeds the surrounding space with heavy elements, enriching interstellar clouds that can later collapse into new stars. In this way, hypernovae might be a kind of cosmic reset button, preventing entire regions of the universe from falling into stagnation. But what happens when hypernovae themselves begin to disappear? As time stretches on, the number of massive stars capable of going hypernova will eventually dwindle. If hypernovae play a crucial role in sustaining galactic ecosystems, then their eventual extinction could signal the beginning of the end. Without them, galaxies would grow old and lifeless, no longer producing new stars at the same rate. Could hypernovae be one of the few forces keeping the universe alive, holding back the slow creep of cosmic decay? And what about the impact of hypernovae on dark matter and dark energy? These two mysterious forces make up the vast majority of the universe's total mass energy, yet we still barely understand how they work. Some physicists have suggested that the energy released by hypernovae might interact with dark matter in ways we don't yet fully comprehend. Could hypernovae be subtly influencing the structure of the universe, shaping the cosmic web in ways beyond what we can currently detect? Then there's the question of what happens inside the black holes formed by hypernovae. When a star goes hypernova and collapses into a black hole, all of its matter is compressed into an incredibly small and dense singularity. But is that truly the end? Some theories propose that black holes might not just be dead zones in space but instead gateways to entirely new realms. Could hypernovae be creating more than just black holes? What if these cosmic explosions are actually generating new universes? The idea of a baby universe, forming inside a black hole has been proposed by some physicists, suggesting that the singularity at the heart of a black hole might be the seed of a new Big Bang. If that's the case, then every hypernova that results in a black hole might be giving birth to an entirely separate reality, one that exists beyond our own. This leads to a mind-bending question: is our own universe the result of a hypernova from some earlier cosmos? If black holes can spawn new universes, then the cycle of cosmic destruction and creation might be far more fundamental than we ever imagined. The multiverse, the idea that countless universes exist alongside or beyond our own, might not just be a theory, but a direct consequence of the life and death of stars. And if this is true, then it means that hypernovae might not just be shaping our universe, they might be responsible for the existence of everything. Every galaxy, every planet, every atom in your body could ultimately trace its origins back to one of these colossal stellar explosions. Hypernovae might be the architects of the cosmos, playing a role so profound that we have only begun to scratch the surface of their significance. But if hypernovae are part of a larger cosmic cycle, then what does that mean for the ultimate fate of everything? Will hypernovae eventually burn themselves out, leading to a cold, lifeless universe? Or could the energy released by these explosions somehow contribute to a cosmic rebirth, restarting the cycle of creation on an even grander scale? These are the kinds of questions that make hypernovae one of the greatest mysteries in the universe. They are more than just massive explosions. They are the engines of cosmic change, forces of destruction and renewal that may hold the answers to the deepest questions about existence itself. And as our understanding of them grows, we may one day uncover truths that challenge everything we think we know about the nature of reality. The implications of hypernovae go beyond just the formation of new stars and the distribution of heavy elements. These colossal explosions may also play a role in shaping the very structure of galaxies. When a hypernova detonates, the sheer force of its explosion can disrupt entire regions of space, potentially triggering waves of star formation, while simultaneously carving out vast voids where matter is blown away. Over time, repeated hypernovae could sculpt the appearance of galaxies, influencing their size, shape, and composition. But the real question is, how many hypernovae does it take to change the course of a galaxy? If these explosions are concentrated in certain regions, could they be responsible for the differences we see between spiral galaxies, elliptical galaxies, and irregular galaxies? Some astronomers believe that hypernovae, especially those that occur in star-forming regions, could be a driving force behind galactic evolution. If true, then hypernovae aren't just the death throes of massive stars. They are a critical part of the grand cosmic cycle that determines how galaxies grow and change over billions of years. And what about their role in cosmic radiation? When a hypernova erupts, it doesn't just release matter, it floods space with powerful radiation, including gamma rays and cosmic rays that can travel across vast cosmic distances. Some of these high-energy particles eventually reach Earth, colliding with our atmosphere and influencing everything from cloud formation to the evolution of life itself. Could it be that hypernovae have directly shaped life on Earth? Some scientists think it's possible. If a hypernova were to explode relatively close to our solar system, the resulting gamma-ray burst could strip away parts of our atmosphere, potentially triggering mass extinctions. In fact, some theories suggest that past extinction events on Earth might have been caused by distant hypernovae. But at the same time, the heavy elements produced by hypernovae, including those essential for life, such as carbon, oxygen, and iron, were necessary for the formation of our planet in the first place. This raises an unsettling paradox. Hypernovae might be both the creators and destroyers of life. Without them, planets like Earth might never have formed, but their deadly radiation could also wipe out life just as easily. It's a cosmic double-edged sword, one that forces us to reconsider our place in the universe. And if hypernovae have the power to shape life on Earth, what does that mean for life elsewhere? Across the galaxy, there could be planets orbiting stars on the brink of going hypernova. If those planets harbor life, then their fate is already sealed. A hypernova in their vicinity would be an unstoppable force of destruction. But at the same time, other planets might be forming from the very remnants of past hypernovae, starting the cycle of life all over again. Could it be that hypernovae are the mechanism through which the universe recycles itself? They destroy, they create, and they spread the building blocks of new stars and planets. In this sense, hypernovae might be one of the most important phenomena in the cosmos, ensuring that the universe remains dynamic and ever-changing. And what about the possibility that hypernovae could be responsible for some of the strangest objects in space? There are cosmic mysteries that defy explanation, bizarre radio signals, unexplained flashes of light, and strange bursts of energy that seem to come from nowhere. Could some of these be the result of hypernovae occurring in ways we don't yet understand? Perhaps there are types of hypernovae that we haven't even discovered yet, ones that produce phenomena so exotic that they challenge the limits of modern physics. Some astrophysicists speculate that certain unexplained cosmic events, like fast radio bursts, FRBs, might be linked to hypernovae. FRBs are brief but incredibly powerful bursts of radio waves coming from deep space. While their exact origins remain a mystery, one theory suggests that hypernovae, particularly those that create magnetars, highly magnetized neutron stars, might be the culprits. If this is true, then every time we detect one of these mysterious signals, we might be witnessing the aftershocks of a hypernova occurring millions or even billions of light years away. And if hypernovae are creating magnetars, then that opens up another set of questions. Magnetars are some of the most extreme objects in the universe, possessing magnetic fields so powerful that they can distort atoms and even affect the fabric of spacetime itself. If hypernovae are responsible for creating these monsters, then what other strange things might they be capable of producing? Could there be unknown remnants of hypernovae that we have yet to discover? Objects so bizarre that they challenge everything we think we know about physics? Then there's the question of scale. We know that hypernovae are among the most powerful explosions in the universe. But could there be something even bigger? What happens when an entire cluster of massive stars reaches the end of its life simultaneously? Could there be a chain reaction of hypernovae, each explosion triggering the next in a cosmic domino effect? If something like this were to happen, the energy release would be unimaginable, potentially rivaling the power of a small galaxy. This brings us to one of the most mind-bending possibilities of all. Could hypernovae be responsible for some of the largest cosmic voids? These are massive regions of space where very few galaxies exist, and scientists have long debated how they formed. If hypernovae can blast material away from star-forming regions, then perhaps, on an even grander scale, a chain of hypernovae could clear out entire portions of the universe, leaving behind the vast cosmic voids we see today. The more we study hypernovae, the more questions arise. They are not just random explosions, they are fundamental to the structure of the universe itself. From the formation of galaxies to the evolution of life, from the distribution of elements to the creation of some of the most extreme objects in existence, hypernovae are at the heart of it all. And yet, despite everything we've learned, the biggest mystery remains: what will hypernovae mean for the future of the universe? Will they continue to shape galaxies and star systems for billions of years to come? Or will they eventually fade away, marking the beginning of the universe's slow march toward darkness? One thing is certain: hypernovae are more than just stellar explosions. They are cosmic architects, reshaping the universe with every burst of energy. They are both creators and destroyers, capable of wiping out entire worlds while simultaneously sowing the seeds for new ones. And as we continue to unlock their secrets, we may one day discover that hypernovae are far more important than we ever imagined, not just for understanding the universe, but for understanding our place within it. Hypernovae are some of the most violent and mysterious phenomena in the universe, but what if they hold secrets we haven't even begun to uncover? Could there be variations of hypernovae that defy our current understanding of physics? Some astronomers speculate that there may be types of cosmic explosions even more powerful than hypernovae, events that push the very limits of what we believe is possible. These theoretical superhypernovae might arise under extreme conditions, perhaps involving exotic matter, dark energy interactions, or even unknown aspects of quantum mechanics. If such explosions exist, they could be responsible for some of the most enigmatic cosmic anomalies we've observed. One of the biggest questions surrounding hypernovae is their connection to dark matter and dark energy. We know that these explosions release an enormous amount of energy, but could they also play a role in the hidden forces shaping the universe? Some theories suggest that the shockwaves from hypernovae might interact with dark matter in ways we don't yet understand, potentially influencing the structure of the cosmos on an unseen level. Others propose that the extreme gravitational forces involved in hypernovae might momentarily disrupt the balance of dark energy, causing subtle fluctuations in the universe's expansion rate. If hypernovae do interact with dark matter and dark energy, could this explain some of the unexplained cosmic phenomena we've observed? There are vast regions of space where galaxies seem to move in ways that defy our models of gravity. Could these strange movements be the lingering effects of past hypernovae influencing dark matter distributions? It's an idea that challenges the way we think about cosmic forces and suggests that hypernovae might be far more important than just stellar explosions. But what about the possibility that hypernovae could open pathways to entirely new dimensions of physics? Some theoretical models propose that the extreme energy densities involved in hypernovae could momentarily create conditions similar to those of the early universe. If this is true, then studying hypernovae might give us insights into the physics of the Big Bang itself. Could these explosions be natural laboratories for understanding the birth of the universe? And what if hypernovae are connected to something even more extreme, cosmic strings or wormholes? Some physicists speculate that under the right conditions, the energy released in a hypernova could be enough to distort spacetime to the point where a temporary wormhole could form. If this were the case, it would mean that hypernovae might not just be shaping the visible universe, but also interacting with unseen dimensions or alternate realities. While this remains a highly speculative idea, it raises the tantalizing possibility that hypernovae could be responsible for some of the most bizarre cosmic events we've ever detected. Even if wormholes are unlikely, hypernovae still push the boundaries of what we know about the nature of space itself. The gravitational waves produced by these explosions ripple through the fabric of spacetime, stretching and compressing it in ways that we can now detect with modern observatories. Every time a hypernova occurs, it sends out these waves, carrying with them information about the explosion, the dying star, and the surrounding cosmic environment. By studying these gravitational waves, scientists can learn more about the internal workings of hypernovae and perhaps uncover new aspects of physics that have remained hidden until now. And then there's the question of scale. Are there places in the universe where hypernovae occur far more frequently than we realize? There may be regions of the cosmos, particularly in young galaxies or dense star clusters, where hypernovae are so common that they create an almost continuous cascade of destruction and creation. If we could find such a place, it might provide us with a unique window into the processes that shape the universe. Some astronomers believe that entire sections of the universe could be shaped by hypernova-dominated environments. These could be vast cosmic furnaces where star formation and destruction happen at an accelerated rate, leading to the rapid evolution of galaxies unlike anything we see in our own cosmic neighborhood. If such regions exist, they might provide critical clues about how the first galaxies formed and how they continue to evolve over billions of years. And if hypernovae are shaping galaxies, could they also influence the distribution of life in the universe? Some scientists have proposed the idea of galactic habitable zones, regions of galaxies where conditions are just right for life to emerge and survive. If hypernovae are too frequent in certain areas, they might make those regions inhospitable by constantly bombarding planets with deadly radiation. But in other areas, where hypernovae have enriched space with the right elements while remaining rare enough to avoid frequent mass extinctions, life might have the best chance to thrive. If this is true, then hypernovae could be one of the main factors determining where life is most likely to exist in the universe. Could we one day use our knowledge of hypernovae to predict where extraterrestrial civilizations might be found? If certain regions of the Milky Way have had just the right balance of hypernova activity, then they might be prime locations to search for intelligent life. And what about the long-term future of hypernovae? Will they continue to occur at the same rate? Or are we living in a unique period of cosmic history where they are more common? As the universe ages, the number of massive stars capable of going hypernova will decline. In 1 trillion years, when most of the largest stars have already exploded, hypernovae might become incredibly rare. What would that mean for the evolution of galaxies and the continued formation of planets? It's possible that hypernovae are a temporary phase in the universe's history, a dramatic but fleeting period in which these massive explosions play a dominant role in shaping everything we see. If so, then we are witnessing a phenomenon that future civilizations in an older universe might never get to experience. But for now, hypernovae remain among the most powerful and awe-inspiring events in existence. They create, they destroy, and they reshape the very fabric of the cosmos. With every new hypernova we discover, we learn more about the universe's past, present, and future. And yet, for all we've uncovered, the biggest mysteries remain unanswered. What other secrets are hidden within these cosmic explosions? Could hypernovae be responsible for some of the strangest, most unexplained cosmic phenomena we've observed? Do they hold the key to understanding the deepest forces of the universe? The search for answers continues, and as we look deeper into space, we may find that hypernovae are even more mysterious than we ever imagined. One of the most puzzling aspects of hypernovae is their unpredictability. While we have a general understanding of the conditions that lead to a hypernova, massive stars reaching the end of their lifespan and collapsing under their own gravity, there are still cases where hypernovae seem to defy expectations. Some stars that should go hypernova don't, while others explode far earlier than our models predict. Could there be unknown variables influencing these explosions? One possible explanation is the role of binary or multiple star systems. Many massive stars exist in systems with one or more stellar companions, and these interactions could significantly alter how and when a star undergoes a hypernova. If a massive star siphons material from a companion, it could accelerate its evolution and trigger an explosion sooner than expected. On the other hand, if two stars merge, the combined mass might result in an even more powerful and unpredictable detonation. And then there's the question of failed hypernovae. What happens when a star collapses but doesn't produce a massive explosion? Some astrophysicists believe that certain stars may skip the hypernova phase entirely, collapsing directly into a black hole without a visible explosion. If this happens, it could explain some of the missing supernovae we expect to see but don't. Could there be a class of silent hypernovae, where all the energy and matter disappear into a black hole without a trace? This idea ties into another mystery: black hole formation. Not all black holes come from hypernovae, but many do. The energy released in a hypernova often dictates what happens next, whether a neutron star forms, a black hole emerges, or something even stranger occurs. Some researchers propose that under extreme conditions, a hypernova could give birth to an entirely new type of exotic object, something beyond black holes and neutron stars, potentially even an unknown form of matter. This leads us to the question of magnetars, the most magnetic objects in the universe. Some hypernovae are thought to create these incredibly dense neutron stars with magnetic fields trillions of times stronger than Earth's. These magnetars emit bursts of high-energy radiation, sometimes disrupting entire regions of space. But could there be an even more extreme version of a magnetar, something beyond our current understanding? Some astrophysicists speculate that hypernovae could be linked to hypothetical objects like Quark stars or even more exotic forms of dense matter. A Quark star, if it exists, would be made of free quarks, the fundamental building blocks of protons and neutrons. The idea is that the pressure inside a hypernova's core could be so intense that neutrons themselves break apart into their quark components, forming a new, ultra-dense type of star. If this is happening, it could explain some of the unusually bright and long-lasting remnants of certain hypernovae that don't match typical supernova or neutron star models. And if quark stars exist, could they eventually collapse into something even more mysterious? Some theories suggest that under the right conditions, a quark star might evolve into a so-called strange star, where strange matter, an even more exotic form of particle interaction, dominates. This kind of matter, if real, could be incredibly stable and almost indestructible, leading to bizarre consequences if even a tiny fragment were to interact with normal matter. But beyond the formation of black holes, neutron stars, magnetars, or even quark stars, some researchers propose an even more radical idea, that hypernovae might produce microscopic black holes, tiny but immensely dense objects that could persist in space for eons. These miniature black holes might not be powerful enough to consume stars, but they could still interact with normal matter in ways we haven't yet observed. Could they be responsible for some of the unexplained gravitational anomalies we detect in deep space? If hypernovae can indeed create these miniature black holes, it raises the question of whether some of them could have been produced early in the universe's history. Could hypernovae in the distant past have seeded the cosmos with tiny, primordial black holes that still roam the universe today? Some researchers have even suggested that these objects might be part of the elusive dark matter that makes up most of the universe's mass, but has yet to be directly detected. And speaking of dark matter, could hypernovae help us understand it better? While dark matter doesn't interact with normal matter in the usual ways, some scientists think that the intense energy of a hypernova might temporarily reveal how dark matter behaves under extreme conditions. If hypernovae emit certain types of radiation or gravitational waves that interact with dark matter differently than expected, we might finally get some clues about what dark matter actually is. The idea of hypernovae interacting with dark matter opens up even more questions. Could there be an unknown form of matter, something even stranger than dark matter, that only appears under these extreme conditions? If so, hypernovae might not just be explosive events but windows into a hidden side of the universe. And then there's the even more speculative idea that hypernovae could be responsible for cosmic ray accelerators. Cosmic rays are high-energy particles that zip through space at nearly the speed of light, bombarding Earth constantly. Some of the most powerful cosmic rays come from deep space, and while we know hypernovae are one of the potential sources, there's still a mystery about how some cosmic rays reach such unimaginable energies. Could hypernovae be acting as natural particle accelerators, flinging protons and other particles across the universe in ways we don't yet understand? If hypernovae are responsible for cosmic rays, could they also be influencing planets and life in ways we haven't considered? When a hypernova explodes, it sends out shockwaves that can travel vast distances. These shockwaves could compress clouds of gas and dust, triggering new waves of star formation. In a way, hypernovae might not just be destructive but also creative forces, helping to shape planetary systems, including, possibly, our own. Some researchers even speculate that hypernovae might have played a role in Earth's history. There is evidence that past mass extinctions on Earth could have been triggered by cosmic events, including supernovae or gamma-ray bursts from hypernovae. If a nearby hypernova were to go off today, could it pose a threat to Earth? And if so, how close would it have to be to cause real damage? The good news is that hypernovae are relatively rare, and the massive stars that produce them are usually found in regions of space far from Earth. However, in a cosmic sense, far is relative. If a hypernova were to occur within a few hundred light-years of Earth, the radiation and particles it emitted could seriously disrupt our planet's atmosphere, potentially stripping away the ozone layer and exposing life to harmful cosmic rays. But could hypernovae also have beneficial effects on life? Some scientists believe that cosmic radiation from hypernovae might play a role in driving evolutionary changes. If high-energy cosmic rays occasionally reach Earth, they could induce genetic mutations, possibly accelerating evolution in unexpected ways. Could it be that hypernovae, in addition to being destroyers, are also catalysts for change? The deeper we look into the mysteries of hypernovae, the more questions arise. Are there types of cosmic explosions beyond hypernovae, events so powerful and extreme that we haven't even detected them yet? Could there be a class of hypernovae that occur under such unique conditions that they don't match anything we've observed? Hypernovae challenge everything we think we know about the universe. They create black holes, send out gamma-ray bursts, accelerate cosmic rays, and might even influence dark matter and the fundamental structure of spacetime itself. As our telescopes become more powerful and our understanding of physics advances, we will undoubtedly uncover even more shocking secrets about these immense cosmic explosions. But for now, hypernovae remain one of the greatest unsolved mysteries in the universe. Hypernovae may hold even deeper secrets about the nature of the universe, secrets that challenge our understanding of physics, space, and even time itself. These immense cosmic explosions don't just release energy. They also reshape the very fabric of the cosmos. Could hypernovae be revealing clues about the underlying structure of reality? One of the most intriguing ideas in modern physics is that hypernovae might produce disturbances in spacetime itself. When a hypernova collapses into a black hole, it distorts the surrounding spacetime, creating powerful gravitational waves, ripples in the fabric of the universe. These waves travel vast distances, stretching and compressing space as they pass. While we've detected gravitational waves from merging black holes and neutron stars, could hypernovae be producing even more exotic types of space-time distortions? Some physicists speculate that in extreme conditions, hypernovae might generate so-called naked singularities, points where gravity is so intense that normal physics breaks down. Unlike black holes, which have an event horizon that shields their singularity from view, a naked singularity would be fully exposed, revealing unknown aspects of physics beyond general relativity. If such objects exist, they could be windows into a deeper theory of gravity, perhaps even quantum gravity, the elusive link between Einstein's relativity and the quantum world. And what about the possibility of wormholes? Some theories suggest that in rare cases, the collapse of a hypernova might not lead to a black hole but instead create a shortcut through spacetime, a wormhole. While purely theoretical, the idea that hypernovae could be natural gateways to distant parts of the universe is tantalizing. If wormholes do form, even briefly, could they be responsible for unexplained cosmic phenomena? Could they explain sudden bursts of energy from unknown sources? There's also the question of dark energy, the mysterious force accelerating the expansion of the universe. Some researchers have proposed that hypernovae might interact with dark energy in ways we don't yet understand. Could the immense energy released in these explosions momentarily alter the balance of dark energy in their local region of space? If so, hypernovae could provide valuable insights into one of the greatest unsolved mysteries of cosmology. And then there's the possibility that hypernovae might reveal something even more fundamental, evidence of extra dimensions. Some versions of string theory propose that our universe has more than the three spatial dimensions we experience, but these extra dimensions are normally hidden. The extreme conditions of a hypernova might briefly expose these dimensions, creating effects that we could potentially detect, such as unusual gravitational waves or anomalies in the distribution of matter after the explosion. Hypernovae might also be revealing clues about the very birth of the universe. Some cosmologists believe that the first stars in the universe, massive, short-lived giants known as population 3 stars, ended their lives in hypernovae unlike anything seen today. These early hypernovae could have played a crucial role in seeding the universe with heavy elements, setting the stage for the formation of planets, galaxies, and ultimately, life itself. But what if hypernovae are more than just cosmic events? Could they be signals? Some researchers have speculated that the universe might host advanced civilizations capable of harnessing the energy of hypernovae. While purely speculative, the idea that an advanced intelligence could manipulate, or even trigger hypernovae raises fascinating possibilities. Could hypernovae be used as beacons, sending messages across the cosmos? Even if hypernovae are purely natural, their connection to life is undeniable. The elements forged in these explosions, iron, gold, uranium, are the building blocks of planets and living organisms. In a way, hypernovae are responsible for everything we see around us. Without them, Earth itself would not exist. But this also raises a more unsettling question: could a future hypernova pose a threat to Earth? While no known hypernova candidate is close enough to endanger us, the universe is vast, and new discoveries are made all the time. If a hypernova were to explode within a few hundred light-years of Earth, the resulting gamma-ray burst could have catastrophic effects on our planet's atmosphere, potentially leading to mass extinctions. Could past hypernovae have influenced Earth's history in ways we haven't yet recognized? As our understanding of hypernovae deepens, so do the mysteries surrounding them. These cosmic behemoths challenge everything we think we know about physics, space, and time. They create black holes, bend space-time, accelerate cosmic rays, and might even reveal hidden dimensions. They are both creators and destroyers, shaping the evolution of galaxies while hinting at forces beyond our comprehension. What other secrets do hypernovae hold? And how many more will we uncover as our technology advances? One thing is certain, hypernovae are among the most powerful and mysterious phenomena in the universe, and their mysteries are far from solved. But even with all we know about hypernovae, there are still many unanswered questions. What triggers some massive stars to collapse into hypernovae instead of regular supernovae? Why do some hypernovae produce long gamma-ray bursts while others do not? Could there be entirely new types of hypernovae that we have yet to discover? One of the biggest mysteries is the exact process by which a collapsing star produces a gamma-ray burst. The most accepted theory is the Quasar model, which suggests that when a hypernova occurs, the star's core collapses into a black hole, forming a rapidly rotating disk of superheated matter around it. This accretion disk funnels jets of energy outward at nearly the speed of light, creating the most intense explosions in the universe. But while this model explains much, it doesn't explain everything. For example, why do some hypernovae produce short-lived bursts of gamma rays while others have extended emissions? Why do some appear to lack strong jets? Could there be multiple mechanisms producing these colossal explosions? Then there's the issue of hypernovae that seem to defy expectations. Some have been observed in environments where we wouldn't expect them, like in galaxies with relatively little star formation. Others seem to release more energy than should be possible given their mass. Could these be signs of new physics at play? Some scientists have proposed that unknown particles or even exotic states of matter might be involved in these outliers. And what about dark matter? We still don't know exactly what dark matter is, but some theories suggest that it could interact with hypernovae in strange ways. Could collapsing hypernova cores be converting some of their matter into exotic dark particles? Could some of the missing mass energy in these explosions be disappearing into the hidden realms of dark matter? There's also the possibility that hypernovae might be linked to even rarer, more extreme cosmic phenomena. Some scientists have theorized the existence of Quark novae, even more powerful explosions that occur when a neutron star collapses into strange matter. These events could dwarf even hypernovae in terms of energy release, creating the densest objects in the universe, quark stars. But have we actually observed a quark nova? If so, could some of the most extreme hypernovae actually be these events in disguise? Then there's another possibility: white holes. Theoretical opposites of black holes, white holes are hypothesized to expel matter and energy instead of sucking them in. Some fringe theories suggest that certain hypernovae might, under the right conditions, trigger the brief formation of a white hole, a momentary reversal of a black hole's collapse. If such an event occurred, it could release energy far beyond anything we've ever seen. And what about the idea that hypernovae might influence the fundamental structure of the universe? Some physicists have speculated that extremely powerful cosmic explosions could interact with the vacuum of space itself. If the fabric of spacetime is not perfectly stable, a hypernova could, in theory, trigger a phase transition, an event that could alter the very nature of reality in its vicinity. This is an extreme idea, but it raises a fascinating question: could hypernovae be linked to the concept of vacuum decay, a theoretical event that could, in the far future, reshape the universe itself? But beyond all the high-concept physics, there's a deeply personal aspect to hypernovae. They remind us of our own small place in the cosmos. These explosions forge the elements that make up our world and our bodies. Every atom of gold in a wedding ring, every trace of iron in our blood, was once part of a star that exploded long ago. Without hypernovae, we would not exist. Yet, hypernovae also remind us of the sheer scale of destruction that exists in the universe. They are both the creators of worlds and the agents of annihilation. They shape galaxies, send out lethal radiation, and leave behind black holes that continue to consume matter for eons. They are the ultimate paradox, cosmic events that bring both life and death on the grandest scale imaginable. So what does the future hold for our understanding of hypernovae? As telescopes grow more powerful, as our ability to detect gravitational waves improves, and as our models of physics advance, we may uncover even more mind-bending details about these celestial titans. Perhaps we will find new kinds of hypernovae, or maybe we'll discover that they are connected to mysteries even deeper than we ever imagined. One thing is certain: The more we learn, the more we realize just how much we still don't know. The universe is vast, violent, and full of secrets. And hypernovae, these massive, universe-shaking explosions, may just be the key to unlocking some of the biggest mysteries of all. While hypernovae are among the most violent events in the cosmos, they might not be the absolute limit of destruction. As we study these colossal stellar deaths, we uncover hints that even more extreme explosions may exist, some predicted by physics, others purely theoretical, and some possibly lurking in the distant reaches of the universe, waiting to be discovered. Hypernovae are already powerful enough to shake entire galaxies. Their energy output, sometimes exceeding 100 times that of a regular supernova, can create shockwaves that trigger star formation thousands of light years away. But what if there are explosions that release even more energy? What if the largest hypernovae we've seen are only the tip of the iceberg? One such candidate for an even greater explosion is the Quark nova. Unlike a hypernova, which ends with a black hole or a neutron star, a quark nova is theorized to occur when a neutron star collapses even further into a quark star, a hypothetical object where neutrons themselves break apart into their constituent quarks. This transition could release energy far beyond even the most powerful known hypernovae. Quark novae, if they exist, would be cosmic nuclear detonations on an unimaginable scale. When a neutron star's core reaches a certain density, the neutrons inside can no longer hold together. They dissolve into an ultra-dense, exotic soup of up, down, and possibly strange quarks, creating a strange matter star. This transition is expected to release an energy burst thousands of times stronger than a hypernova, sending shockwaves rippling across the galaxy. Some scientists believe that we may have already seen hints of quark novae. There have been a handful of supernova explosions that were unexpectedly powerful, leaving behind remnants that don't fit the normal pattern of neutron stars or black holes. These outliers suggest that there could be an intermediate step, a quark nova, creating an entirely new class of stellar remnants. And if quark novae exist, they might also explain some of the brightest gamma-ray bursts ever recorded. Unlike hypernovae, which have relatively well-understood jet structures, some gamma-ray bursts are so extreme that they defy current models. Could these be the fingerprints of quark novae? If so, then we are only beginning to understand the true limits of stellar destruction. But what if we push even further? Could there be something even more catastrophic than a quark nova? One of the most speculative yet mind-blowing possibilities is that some cosmic explosions might involve white holes, theoretical objects that are the opposite of black holes. While a black hole pulls everything in, a white hole does the reverse, expelling matter and energy in an uncontrollable burst. White holes have never been observed, and their very existence is still debated. But if they do exist, they could be the result of certain black holes, bouncing back from their collapse, spitting out energy that had been trapped inside. Some researchers have speculated that certain hypernova-like explosions might actually be failed black holes briefly turning into white holes before disappearing. If such an event occurred, it would release an unimaginable amount of energy. Unlike a hypernova, which can last days or weeks, a white hole explosion would likely happen in an instant, an enormous pulse of radiation sweeping across the universe like a cosmic flashbulb. It could create the brightest explosion in the cosmos, outshining entire galaxies before vanishing forever. But we can go even deeper into the unknown. What if there was a type of explosion that didn't just destroy a star, but instead destabilize the very fabric of spacetime itself? Some physicists have theorized that certain cosmic explosions might be capable of triggering vacuum decay, a terrifying event in which spacetime undergoes a catastrophic transformation. The idea of vacuum decay is based on quantum field theory. Right now, our universe exists in what physicists call a false vacuum, a stable state, but not the most stable possible. If a tiny region of space were to collapse into a lower energy state, it could trigger a chain reaction, spreading outward at the speed of light and rewriting the very laws of physics. Could a hypernova, or something even stronger, like a quark nova or a white hole event, trigger such a vacuum decay event? If so, it would be the most extreme cosmic explosion imaginable, not just destroying a star or a galaxy, but effectively rebooting the entire universe itself. Thankfully, most physicists believe that our universe is in a truly stable state, meaning vacuum decay is unlikely to occur naturally. But if the universe has hidden weaknesses, if there are regions of space where extreme energy levels could push reality over the edge, then hypernovae, and their even more extreme counterparts might hold the key to one of the most unsettling possibilities in all of science. The more we learn about hypernovae, the more we realize that they are only the beginning. From quark novae to white hole eruptions to the mind-bending possibility of vacuum decay, the cosmos may hold even greater explosions than we ever imagined. Each new discovery pushes the limits of what we thought was possible, revealing a universe that is not only vast and mysterious but also filled with forces of unimaginable power. And perhaps the greatest mystery of all is this: if hypernovae are common in the universe, and if even more extreme cosmic explosions exist, then what unseen forces might be shaping our own galaxy, right now, at this very moment? Could there be a hypernova brewing in a distant star system, waiting to unleash its fury? Could a quark nova have already exploded in some hidden corner of the universe, its effects yet to reach us? And if so, what might we learn when we finally witness the largest cosmic explosion of all? The idea that even larger cosmic explosions could be lurking in the universe is both awe-inspiring and terrifying. Hypernovae, quark novae, white hole eruptions, and vacuum decay events push the boundaries of what we understand about the cosmos. But what if there were even more exotic forms of cosmic destruction, ones that challenge not only our knowledge of astrophysics but the very fabric of existence itself? Some researchers speculate about black hole collisions producing ultra-powerful explosions. When two black holes merge, they typically release energy in the form of gravitational waves, ripples in spacetime. But what if, under the right conditions, these mergers could also produce bursts of radiation far more energetic than any hypernova? The idea hinges on the existence of primordial black holes, theoretical remnants from the early universe. Unlike the supermassive black holes found in galaxies today, these would have formed in the chaotic aftermath of the Big Bang, with some potentially smaller than a grain of sand but more massive than a mountain. If two primordial black holes were to collide, their energy output might not just be limited to gravitational waves. It could result in an event more powerful than any supernova, possibly detectable as ultra-high-energy gamma-ray bursts. But even more extreme is the possibility of Planck-scale explosions, events where quantum gravity effects come into play. If a black hole were to shrink down to the Planck length, a scale at which spacetime itself ceases to behave normally, some theories suggest it could trigger a final, catastrophic outburst of energy. This would be the ultimate end of a black hole, evaporating in an explosion even more powerful than a quark nova or white hole eruption. And what about the possibility of dark matter detonations? Dark matter remains one of the greatest mysteries in cosmology. We know it's there. It makes up about 85% of the universe's total mass. But we have no direct evidence of what it actually is. Some theories suggest that under certain conditions, dark matter particles could interact in ways that lead to self-annihilation on a massive scale. If a dense enough cluster of dark matter were to form in the core of a dying star, it might trigger an explosion unlike anything we've ever seen. Unlike a normal hypernova, which relies on nuclear fusion and gravitational collapse, a dark matter detonation would be driven by exotic physics, possibly releasing more energy than an entire galaxy in a single moment. The search for these ultra-rare explosions is ongoing. Astronomers are constantly scanning the universe for unexplained flashes of light, gamma-ray bursts that don't fit known patterns, and gravitational wave signals that could hint at something beyond our current understanding. Every so often, we detect cosmic events that defy explanation, bursts of energy so powerful that they force us to reconsider what's possible. If we do discover an explosion greater than any hypernova, it could change everything we know about the universe. Could such an event have played a role in shaping the cosmos itself? Could a quark nova or white hole eruption have triggered the formation of new galaxies? Could a vacuum decay event, somewhere far beyond our visible universe, have rewritten the laws of physics in a distant cosmic bubble? The largest cosmic explosions are not just fascinating astronomical phenomena. They may hold the key to understanding the universe's past and its future. If a hypernova can destroy a star and shape new worlds, what could an even greater explosion do? Could it be possible that, one day, an event of unimaginable power could occur close enough to impact our own galaxy? For now, we can only watch and wait, staring into the depths of space, searching for the next great explosion that will challenge everything we think we know. And when we finally witness the largest cosmic explosion ever recorded, what secrets will it reveal? If the universe has taught us anything, it's that the unimaginable is often real. The largest cosmic explosions we've discussed, hypernovae, quark novae, white hole eruptions, and even dark matter detonations, are just the beginning. But what happens when we push beyond even these cataclysmic forces? What lies in the realm of theoretical physics, where energy levels go beyond our current observations, and where the very fabric of reality might be at risk? One of the most extreme ideas comes from the concept of vacuum decay, a phenomenon that could annihilate everything we know in an instant. In modern physics, we assume that the universe exists in a stable state, meaning that the quantum vacuum, the lowest energy state of the universe, is truly the lowest it can go. But what if that assumption is wrong? If we are living in a false vacuum, rather than a true vacuum, then the universe is only temporarily stable. A high-energy event, such as the collision of two neutron stars or the intense conditions inside a black hole, could trigger a process called vacuum decay. This would send a bubble of destruction expanding at the speed of light, wiping out everything in its path, including stars, galaxies, and even the laws of physics themselves. What's terrifying about vacuum decay is that it wouldn't look like an explosion from the outside. We wouldn't see it coming. The moment the bubble of true vacuum reached us, reality as we know it would simply cease to exist. The universe would be replaced by something else, something with entirely new laws of physics, new particles, and possibly even new dimensions. While vacuum decay is purely theoretical, there are other extreme cosmic explosions that are more grounded in observable physics. Black hole superradiance, for example, is a process in which rotating black holes interact with exotic particles, producing massive energy emissions that could rival hypernovae. This process is tied to theories about axions, a type of hypothetical particle that may exist in large quantities in the universe. If axions cluster around a spinning black hole, they can form a cloud that extracts rotational energy from the black hole itself. When this energy is finally released, it could result in an explosion far beyond any known supernova. Then there are kilonovae, explosive events caused by the merger of two neutron stars. While not as powerful as a hypernova, a kilonova produces intense bursts of gamma rays and creates massive amounts of heavy elements, including gold and platinum. Some researchers believe that certain kilonovae could be even more extreme, producing magnetar formation events, where a rapidly spinning neutron star with an incredibly strong magnetic field is born. If such a magnetar were to collapse into a black hole, the resulting explosion could be more energetic than any hypernova ever recorded. Even more speculative is the idea of cosmic string collapses, a phenomenon tied to string theory. If cosmic strings, hypothetical one-dimensional defects in spacetime, exist, their collisions or collapses could release energy on an unprecedented scale. A collapsing cosmic string might unleash a burst of gravitational waves and high-energy radiation more powerful than anything we've ever detected. And then there's the possibility of Big Bang-like events occurring within the universe itself. Some theories suggest that what we think of as the Big Bang might not have been a one-time occurrence. Instead, new universes could be forming all the time through a process called eternal inflation. If a pocket of space within our universe undergoes rapid inflation, it could create a new universe within our own. To an outside observer, this event would appear as an unbelievably powerful explosion, perhaps the most powerful of all. The search for the largest cosmic explosions is ongoing. As our telescopes become more advanced and our understanding of physics deepens, we may one day witness an event that defies everything we thought was possible. What happens when we finally detect the most energetic explosion in the universe? Will it be the birth of something new, or the end of everything we know? If we've learned anything from the most extreme cosmic explosions, it's that the universe is always capable of surprising us. The most violent forces we've observed, hypernovae, kilonovae, quark novae, and even the theoretical possibilities of vacuum decay and cosmic string collapses, are just glimpses into the raw power that space can unleash. But what if there are even more extreme forces at play, events that stretch the very limits of physics itself? One of the most mind-bending ideas is the concept of Planck energy explosions, which exist purely at the edge of theoretical physics. The Planck scale represents the smallest possible units of time, space, and energy that we can comprehend with our current understanding of quantum mechanics and relativity. At this scale, the fabric of spacetime itself becomes unstable, and normal physics breaks down. If an object or particle were to reach the Planck energy level, it could trigger a spacetime rupture, a literal tear in the universe. Some physicists believe that this could happen inside the intense environment of a black hole, or during the collision of ultra-high-energy cosmic rays. If such a rupture occurred, the explosion would make hypernovae look trivial. It would be an event so powerful that it might birth an entirely new region of spacetime, creating a pocket universe right before our eyes. Another potential extreme explosion is the idea of brane collisions from string theory. In some versions of string theory, our universe is like a three-dimensional membrane, or brane, floating within a higher dimensional space. If two such branes were to collide, the resulting explosion could be equivalent to a second Big Bang. In this scenario, an entirely new universe could form, while our own universe is either altered beyond recognition or destroyed in the process. Then there's the possibility of dark energy detonations, which tie into the mysterious force that is accelerating the expansion of the universe. Dark energy is one of the biggest mysteries in physics, and we still don't fully understand what it is. But some theories suggest that if dark energy were to become unstable, it could release a catastrophic burst of energy that would ripple across the cosmos. This would not just destroy galaxies, it could completely rewrite the underlying structure of space-time itself. One even more bizarre possibility is the spontaneous formation of a black hole bomb. This idea is linked to the concept of black hole superradiance, which we touched on earlier. If certain particles, such as axions, accumulate around a rotating black hole, they can extract energy from the black hole itself. If enough energy builds up, the entire system could collapse into a massive explosion, releasing an unimaginable amount of radiation and possibly even sending shockwaves across the entire universe. But what if the biggest cosmic explosion hasn't happened yet? What if the entire universe is building up to an ultimate catastrophic event? Some physicists suggest that the universe is in a metastable state, meaning that it might one day undergo a phase transition, like water suddenly turning into ice. If this happens, the fundamental forces of the universe could shift, causing every atom, every star, and every black hole to instantly disintegrate. This would be the final explosion, an event that doesn't just destroy everything, but fundamentally alters the very nature of reality itself. The truth is, we are still in the early stages of understanding the universe's most extreme explosions. Every time we think we've discovered the ultimate cosmic event, a new theory emerges that takes things to an even greater level. Could there be forces out there capable of destroying not just galaxies, but the very laws of physics? Could we one day witness an explosion so powerful that it reshapes the cosmos in ways we can't even imagine? The universe is vast, and its mysteries are endless. And perhaps, the most extreme explosion of all is still waiting to be discovered. The universe is a place of unimaginable violence. We've talked about hypernovae, quark novae, and the mind-bending possibility of Planck energy ruptures. But what if there are even bigger, even more catastrophic events lurking out there? What if the most extreme cosmic explosion isn't something we've seen yet, but something waiting to happen? Something so powerful that it reshapes the entire universe as we know it. One of the most terrifying possibilities is the Big Rip, a scenario in which dark energy doesn't just push galaxies apart, it rips apart the very fabric of spacetime itself. Right now, the universe is expanding at an accelerating rate, driven by this mysterious force we call dark energy. But what if this acceleration increases without limit? Instead of a slow and steady expansion, dark energy could become stronger over time, pulling galaxies apart faster and faster until even individual stars, planets, and eventually atoms themselves are torn apart. At first, galaxies would separate so quickly that light could no longer travel between them. Then, entire solar systems would be shredded as the force overcomes gravity. Eventually, planets, moons, and even the solid structure of matter itself would unravel as molecules are ripped from each other. And at the very end, even subatomic particles, the very building blocks of reality, would be pulled apart into nothingness. The final explosion wouldn't be a singular burst of energy, but rather a complete breakdown of the entire structure of existence. But what if, instead of being torn apart, the universe collapses in on itself? This brings us to the Big Crunch, the opposite of the Big Rip. Instead of accelerating expansion, imagine if gravity eventually overcomes dark energy and pulls everything back together. Over billions of years, galaxies would start falling toward one another, clustering together into enormous superstructures. As time goes on, these clusters would merge into a single, incomprehensibly massive object. The temperature of the universe would rise as matter is compressed into an ever-shrinking space. At some point, the universe would become a single, superheated mass, denser than anything we can imagine. Temperatures would reach trillions upon trillions of degrees, fusing atoms into heavier elements until even fundamental particles could no longer maintain their structure. The laws of physics themselves might begin to break down as everything collapses into a singularity, a point of infinite density. This would be the ultimate cosmic explosion in reverse, ending with a final implosion that could either mark the true end of everything or the beginning of something new. Some theories suggest that the universe doesn't end with a big crunch, but instead bounces back into a new state. This idea, called the Big Bounce, proposes that the universe is cyclic, constantly expanding and contracting in an infinite loop. If this is true, then the end of our universe might just be the spark that ignites the birth of another. The final collapse would trigger a burst of unimaginable energy, resetting the cosmos and starting the cycle all over again. But what if the biggest explosion isn't something that happens naturally, but something that is artificially created? Some physicists have speculated about the possibility of a false vacuum decay, an event that could be triggered by an advanced civilization or by a natural quantum fluctuation. To understand this, we need to talk about what's known as the vacuum state. The vacuum of space isn't actually empty. It has an energy level, called the vacuum energy. Right now, our universe exists in what's called a false vacuum state, meaning it's stable, but not necessarily the most stable state possible. If even a tiny part of the universe transitioned into a lower energy state, it could trigger a chain reaction that spreads at the speed of light, fundamentally changing the rules of physics as it moves outward. In an instant, atoms might no longer hold together. The forces that govern reality, gravity, electromagnetism, nuclear interactions, could shift into entirely new forms. Every structure in the universe would vanish in an explosion that doesn't just destroy matter, but rewrites existence itself. And the terrifying part? If this ever happens, we wouldn't even see it coming. The event would propagate at the speed of light, meaning by the time we noticed something was wrong, it would already be over. But what if there's an even bigger, even more unfathomable explosion out there? What if entire higher dimensions are colliding beyond our perception, causing universe-shattering explosions that we can't even comprehend? Some theories suggest that our universe is just one of many, existing in a vast cosmic landscape of parallel realities. If two of these universes were to interact, collide, merge, or even graze each other, the energy release could be beyond anything we could ever measure. Imagine an explosion that doesn't just release energy, but creates an entirely new dimension of space. Imagine the very concept of time itself being reset, erasing the past and reshaping the future. If two universes collided, the resulting explosion might not just destroy everything inside them, but create something entirely new, perhaps an even more complex reality, or a complete void where no physics exists at all. The deeper we look into the cosmos, the more we realize how little we understand. Hypernovae, quark novae, gamma-ray bursts, these are just the beginning. The universe has been around for nearly 14 billion years, but we're only scratching the surface of its mysteries. Could the biggest cosmic explosion still be ahead of us? Could something even more powerful than everything we've talked about be waiting in the distant future, or lurking beyond the edge of our observable universe? For now, we can only guess. But one thing is certain: the universe is far more violent, far more extreme, and far more mysterious than we ever imagined. And the most powerful explosion of all may be something we haven't even begun to comprehend. The idea of cosmic explosions beyond anything we've ever observed raises a haunting question. Is there a limit to how powerful an explosion can be? We've explored hypernovae, quark novae, false vacuum decay, and even the unimaginable collisions of entire universes. But what if there's something even more extreme, something that defies our understanding of physics itself? One possibility lies in the death of black holes. Black holes are often seen as the ultimate devourers of matter, consuming anything that falls past their event horizon. But what happens at the very end of a black hole's life? According to quantum mechanics, black holes slowly lose mass over time through a process called Hawking radiation. This means that, over an incredibly long period, far longer than the current age of the universe, black holes will eventually shrink and evaporate. But when a black hole reaches its final moments, something extraordinary could happen. As it gets smaller, the amount of Hawking radiation it emits increases. In the final milliseconds, the black hole would release an enormous burst of energy in what might be one of the most violent explosions possible. Some scientists theorize that this explosion could be far more powerful than even a hypernova, releasing more energy in an instant than entire galaxies do in millions of years. This raises an even stranger possibility. What if some black holes, under the right conditions, don't just evaporate, but instead explode in a way that triggers a completely new phenomenon? Some theories suggest that black holes could store exotic forms of energy, or even act as gateways to other dimensions. If a black hole were to suddenly rupture or collapse in an unexpected way, the result could be an explosion that alters the structure of spacetime itself. But there's something even more unsettling to consider. If black holes can explode, what about white holes? Theoretically, a white hole is the opposite of a black hole, an object that can't absorb anything, but instead only expels matter and energy. White holes remain purely hypothetical, but if they do exist, they might be the most powerful cosmic explosions of all. Imagine a white hole suddenly appearing in space, unleashing all the matter and energy of a collapsed black hole in an instant. It would be like rewinding the process of a black hole's formation but playing it back at infinite speed. The result would be an explosion so powerful that it might create new galaxies, or even new universes. Some scientists have even proposed that the Big Bang itself might have been a white hole explosion, a singularity in reverse, spewing out everything that became our cosmos. If that's the case, then perhaps white holes aren't just rare phenomena, but fundamental to the very nature of reality. This brings us to one of the most extreme possibilities of all: vacuum collapse events on a cosmic scale. We've already talked about false vacuum decay, where the fabric of reality itself could be rewritten. But what if there are multiple layers of vacuum states, and a deeper, more stable vacuum state exists beyond our reach? If this were the case, then a sudden collapse from our current vacuum state to a lower one could trigger an explosion unlike anything we've ever imagined. Such an event wouldn't just destroy matter, it would reshape space, time, and the fundamental constants of physics. The speed of light could change. The strength of gravity could shift. Entire galaxies could vanish as their atoms disintegrate into unknown forms of energy. It wouldn't be an explosion in the traditional sense. It would be a reset of reality itself. This idea leads us to the possibility of multiversal collisions. If our universe is just one of many in a vast multiverse, what happens when two universes interact? If universes exist in higher dimensional space, they might occasionally collide or merge. Such an event could release energies beyond human comprehension, tearing through the fabric of spacetime and creating entirely new cosmic structures. Some theories even suggest that the birth of our universe might have been caused by such a collision. If true, then these unimaginable cosmic explosions aren't just hypothetical. They may have already happened, and they may happen again. Could our universe someday collide with another, triggering a new Big Bang and wiping out everything we know? The most mind-bending possibility is that cosmic explosions aren't just events, they're the fundamental engine driving reality itself. Perhaps the universe is an endless cycle of explosions, collapses, and rebirths. Perhaps every black hole death, every white hole eruption, every vacuum collapse, and every multiversal collision is just part of a never-ending chain of creation and destruction. We may never fully understand the limits of cosmic explosions, but one thing is certain: the universe is far more powerful, unpredictable, and extreme than we can possibly imagine. And the most devastating explosion of all? It could be happening right now, somewhere beyond the edge of what we can see, reshaping reality in ways we'll never know. If cosmic explosions are the fundamental engine of reality, then the biggest question of all is, are we living in a universe that is still exploding? Most people think of the Big Bang as a singular event, a massive explosion that happened once and then faded into the past. But what if that explosion never truly stopped? What if we are still inside the detonation of the most powerful cosmic event in existence? Scientists have long debated the fate of the universe. Will it expand forever, or will it one day collapse back in on itself? Right now, the evidence suggests that the universe is not only expanding but accelerating. Something unseen, something we call dark energy, is pushing galaxies apart at an ever-increasing rate. But what if this acceleration is actually the tail end of an explosion that began with the Big Bang? Imagine a firework exploding in slow motion. At first, all the sparks fly outward rapidly. But as time goes on, they continue expanding outward, never stopping. This might be exactly what's happening with our universe. The Big Bang may not have been a one-time event but a continuous process, an explosion that is still unfolding, billions of years after it began. But if the Big Bang is still happening, could it also happen again? Some theories suggest that the universe might go through cycles of expansion and contraction. This is known as the Big Bounce theory. In this model, the universe doesn't just explode once, it collapses and then explodes again, endlessly repeating. But there's another possibility, one that is even more terrifying. Instead of bouncing, what if the universe one day encounters a new kind of cosmic explosion? Something even bigger than the Big Bang itself. One way this could happen is through a cosmic phase transition, a sudden shift in the very nature of space-time. The laws of physics we experience today might not be fixed forever. They could be temporary, waiting for the next transition into a completely different state. If such an event occurred, it would be the ultimate cosmic explosion, not just a release of energy, but a rewriting of the universe itself. Some physicists speculate that these transitions could be triggered by exotic objects like cosmic strings, ultra-dense filaments of energy left over from the Big Bang. If two cosmic strings were to collide, they could release energies beyond anything ever imagined. The resulting explosion wouldn't just tear apart space, it might create new universes in its wake. But the most extreme possibility of all is that cosmic explosions aren't random, they are deliberate. What if advanced civilizations, far beyond our understanding, have found ways to trigger cosmic-scale explosions? The idea might sound like science fiction, but some physicists have seriously considered the concept of universal engineering, the possibility that an advanced intelligence could manipulate the fabric of space-time itself. If a civilization had access to the energy of a black hole, a neutron star, or even an entire galaxy, they might be capable of triggering a controlled explosion, a detonation so powerful that it could reshape the cosmos. Some have even proposed that the mysterious signals we occasionally detect from deep space, such as fast radio bursts, might be the signatures of such experiments. Could we, one day in the distant future, become a species capable of wielding such power? Could humanity itself play a role in triggering the next great cosmic explosion? And if so, would we do it out of curiosity, necessity, or something else entirely? The greatest cosmic explosions may not be behind us. They may still be waiting to happen. Somewhere in the depths of space, beyond what we can see, the next unimaginable detonation may already be beginning. And if we ever witness it, it could change everything we know about the universe, and our place in it. The idea that the universe itself could still be in the process of exploding is just one of many mind-bending possibilities when it comes to cosmic detonations. But what if the most extreme explosions haven't even happened yet? What if somewhere out there, in the vast darkness beyond what our telescopes can see, a truly unimaginable event is waiting to occur? Something that would make hypernovae look like mere sparks in comparison. To understand how the most extreme cosmic explosions could happen, we have to go beyond what we currently know. We've talked about hypernovae, magnetar flares, and even gamma-ray bursts, but there's another level of destruction, events so powerful that they could tear apart the very fabric of the universe itself. These are cosmological detonations, explosions that don't just destroy stars or galaxies, but may change the fundamental nature of reality. One possibility is the vacuum decay apocalypse, a theoretical cosmic event that, if triggered, would propagate outward at the speed of light, rewriting the universe as it goes. This idea comes from quantum physics, which suggests that what we call empty space isn't actually empty at all. Instead, it exists in a certain energy state, a kind of equilibrium that allows particles, forces, and even time itself to behave the way they do. But what if that equilibrium isn't permanent? What if, somewhere in the universe, a quantum fluctuation or a high-energy event, perhaps a collision between two black holes or the death of a neutron star, accidentally creates a true vacuum bubble? If this were to happen, it would mean that the laws of physics inside that bubble would be different from the laws of physics we experience. And because nature tends to favor lower energy states, this true vacuum bubble would begin expanding at the speed of light, erasing and rewriting everything in its path. Stars, galaxies, and even black holes wouldn't just be destroyed, they would cease to exist in any recognizable form. The terrifying part? If vacuum decay were to begin somewhere in the universe, we wouldn't see it coming. Because it would travel at the speed of light, the first sign of its arrival would be our instant annihilation. The very atoms that make up our bodies would be rewritten into something unrecognizable, and we wouldn't even have time to understand what was happening. But what if there were ways to trigger such an event deliberately? Some physicists speculate that advanced civilizations, capable of manipulating energy on a cosmic scale, might one day develop technology that could artificially trigger vacuum decay. In other words, a civilization could wield the power to destroy the entire universe, not just a planet, not just a galaxy, but everything. This brings up another disturbing question. Could vacuum decay be a natural part of the life cycle of universes? If the multiverse is real, then perhaps different universes are born, evolve, and eventually collapse into new vacuum states, birthing new universes in the process. Could we be living inside a universe that was created by the detonation of a previous one? And if so, could our own universe one day collapse and give rise to another? This idea is closely related to the theory of Big Rip scenarios, where dark energy doesn't just cause the universe to expand forever but actually tears it apart. Right now, dark energy is causing galaxies to move away from each other faster and faster. But if dark energy's influence were to increase over time, it could reach a point where it begins to pull apart atoms themselves. This would be the ultimate cosmic explosion, not an explosion outward, but a tearing apart of the very fabric of existence. First, galaxies would separate. Then, solar systems would be pulled apart. Then, planets, atoms, and even subatomic particles would disintegrate as space itself expands faster than the speed of light. The final moment would be an unimaginable release of energy as the universe itself ceases to exist in its current form. But what if, instead of destroying everything, this process creates something new? Some physicists believe that when one universe reaches its end, the energy released might be enough to spark the birth of another. Imagine a vast cosmic explosion not as an ending, but as a beginning, the Big Bang of an entirely new reality. If that's true, then hypernovae, gamma-ray bursts, and even black hole mergers are just tiny echoes of the true explosions that govern the life cycle of the cosmos. And if we are living in a universe that came from a previous explosion, then one day, far in the future, our universe, too, might detonate in a way beyond anything we can currently imagine. If that day comes, will we be here to witness it? Will we, as a species, have advanced enough to escape? Or will we simply be swallowed up in an explosion greater than any that has ever been seen before? These are the mysteries that keep scientists awake at night. Because in the end, the universe itself may be nothing more than an endless cycle of explosions, destruction, and rebirth. If the universe is truly governed by cycles of explosions and rebirth, then the most extreme cosmic events may not just be violent ends, but also the seeds of new beginnings. Every hypernova, every black hole merger, and even the unimaginable vacuum decay scenario might just be a small part of a far greater process, one that stretches beyond the limits of what we can observe. But what happens when we go even deeper? What if we explore the very edges of theoretical physics and look at the most extreme cosmic detonations possible, ones that may not have even occurred yet? One of the most terrifying possibilities involves quark stars and strange matter explosions. When a star dies and collapses into a neutron star, it crushes protons and electrons together so tightly that only neutrons remain. But under even greater pressure, those neutrons themselves can break down into something even more fundamental: quarks, the tiny building blocks of all matter. A quark star, if it exists, would be an object so dense that it's right on the edge of becoming a black hole, but with a key difference. Some scientists believe that quark matter might be stable in a way that ordinary matter is not. And if that's true, it could lead to one of the most terrifying explosions in the universe, a strange matter conversion event. Here's how it works. If quark matter is stable, then any ordinary matter that touches it might be forced to transform into the same state. This is called the strange matter hypothesis, and if true, it means that a single piece of strange quark matter could start a chain reaction. If a neutron star were to turn into strange matter, it could release an enormous amount of energy in an explosion more powerful than any hypernova. But the worst part: if a chunk of this strange matter were to somehow reach Earth, perhaps from a collision between two quark stars, it could theoretically infect our planet, turning all ordinary matter into strange matter in a fraction of a second. Earth and everything on it would instantly collapse into a dense, featureless mass with no warning. And that's just the beginning. If strange matter truly exists and is more stable than normal matter, then it's possible that most of the matter in the universe has already been converted. We just haven't encountered it yet. If that's true, then entire galaxies could have undergone strange matter detonations, turning into invisible, ultra-dense regions of space that we don't even recognize. Could this explain some of the unaccounted for dark matter in the universe? Could we be on the verge of discovering a form of cosmic explosion that hasn't been observed yet, but is already shaping the fate of galaxies? Then there's an even bigger question: what happens when entire black holes explode? Normally, black holes don't explode. They swallow everything, including light, without ever releasing it again. But according to Hawking radiation, black holes actually do lose tiny amounts of energy over vast periods of time. And if Stephen Hawking's calculations were correct, then a black hole should eventually shrink and, in its final moments, explode. But what if there are ways for black holes to explode before they naturally evaporate? Some scientists believe that certain extreme events, such as a sudden collision between two black holes or the introduction of exotic negative energy, could destabilize a black hole in an instant. If this were to happen, it could trigger an explosion unlike anything seen in the universe. Unlike a hypernova or a gamma ray burst, a black hole detonation wouldn't just release energy. It might create an entirely new region of spacetime, possibly even a new universe. And if that's true, then the Big Bang itself might not have been the first event of its kind. What if every black hole in our universe is a ticking time bomb, waiting for the right conditions to explode and give birth to a new reality? Could we be living in the aftermath of one such explosion? And if so, are there other universes, formed from detonated black holes, waiting just beyond our reach? This leads to one of the most extreme ideas in all of physics: the Big Crunch and the next Big Bang. Some theories suggest that our universe isn't expanding forever, but will eventually slow down, collapse back on itself, and then explode outward again in a new Big Bang. If this cycle has happened before, then we might not be living in the first universe at all, just the latest in an infinite series of cosmic explosions. Could hypernovae, gamma ray bursts, quark star detonations, black hole explosions, and vacuum decay events all be connected in ways we don't yet understand? Are we just tiny observers in a universe that is constantly destroying and recreating itself? And if so, will we ever witness the ultimate cosmic explosion, the moment when everything we know disappears and something new is born in its place? One thing is certain: the universe is far more violent, unpredictable, and explosive than we ever imagined. And as we continue to explore, we may find that even the most extreme cosmic events we know of today are just tiny echoes of something even greater. If the universe is truly governed by cycles of explosions and rebirth, then we may only be scratching the surface of what cosmic destruction is capable of. Hypernovae, gamma-ray bursts, and even the theoretical explosions of quark stars and black holes are already some of the most energetic events we can conceive. But what if we go even deeper? What if we consider cosmic explosions so vast that they don't just affect a single star or galaxy, but reality itself? One of the most extreme and least understood cosmic events is the idea of a white hole explosion. Unlike black holes, which pull everything in and never let anything escape, a white hole is theoretically the opposite. It ejects matter and energy outward but never allows anything to enter. If white holes exist, they could be the most violent objects in the universe, constantly spewing out matter in a process that looks like an explosion without end. But here's the catch: we've never observed a white hole, at least not directly. Some physicists believe that white holes might be the final, explosive phase of a black hole's life. When a black hole reaches the end of its lifespan and can no longer sustain itself, it might suddenly burst into a white hole, ejecting everything it ever consumed in a single, incomprehensibly violent explosion. If this were to happen, it would make a hypernova look like a sparkler in comparison. And there's another even more bizarre possibility. Some theorists suggest that our entire universe was born from a white hole explosion, that the Big Bang itself wasn't just a spontaneous event but the result of another reality's black hole collapsing and releasing everything it had consumed into a new universe. If this is true, then black holes could be gateways to other universes, and every explosion of a white hole might be the beginning of a brand new cosmos. But this idea leads us to something even more terrifying: the vacuum decay catastrophe. This is one of the scariest theoretical explosions in all of physics because if it happens, we wouldn't see it coming. Right now, the universe exists in what's called a false vacuum. It seems stable, but it might not be. Some physicists believe that there's a more stable state of the universe called the true vacuum. If, for any reason, a tiny patch of space were to suddenly transition into this true vacuum state, it would trigger a chain reaction faster than the speed of light, annihilating everything in existence in an instant. Stars, galaxies, black holes, everything would be destroyed, rewritten into something entirely new in a cosmic explosion beyond all comprehension. And the worst part? If vacuum decay has already begun somewhere in the universe, we never see it coming. A single tiny quantum fluctuation could be enough to start the process, and once it begins, it would expand at the speed of light. That means one moment we'd be here, and the next moment, without warning, the laws of physics themselves would be rewritten in an instant. But what if even vacuum decay isn't the most extreme cosmic explosion possible? What if, instead of an explosion that happens in the universe, we consider explosions that happen to the universe itself? One of the most radical theories in modern physics is that our entire reality is part of a much larger, higher-dimensional space. If that's true, then our universe might not be the only one. There could be countless other universes, each with their own laws of physics, existing in a vast higher-dimensional structure. And if universes can exist separately, what happens if two of them collide? The collision of two universes, sometimes called a brane collision, would be an event so massive that it would make even the biggest hypernova look like nothing. Some physicists believe that such a collision could be responsible for the Big Bang itself. In this scenario, our universe wasn't just born from nothing, it was the result of two higher-dimensional realities slamming into each other with unimaginable force, creating an explosion that didn't just destroy stars or galaxies, but created time, space, and matter itself. If this theory is correct, then cosmic explosions aren't just a part of the universe's life cycle. They are the universe's life cycle. Every black hole explosion, every hypernova, every vacuum decay event could be part of a grander cosmic process, one in which universes are constantly being created and destroyed in a never-ending cycle. So what does this mean for us? Are we living inside the aftermath of one such explosion? And if so, will our universe eventually meet its own violent end, only to give rise to something new? The more we learn about cosmic explosions, the more we realize that destruction and creation are two sides of the same coin. The universe may be a vast and violent place, but in that violence lies the possibility of something even greater, a mystery we are only just beginning to understand. If cosmic explosions are truly part of an endless cycle of creation and destruction, then we must ask, what comes after the most extreme cosmic events? Does the universe rebuild itself? Does it fade into silence? Or does something even more chaotic follow? One of the most fascinating ideas in modern physics is that explosions on the grandest scale may not just be about destruction, but about reshaping reality itself. We've already explored hypernovae, white hole eruptions, vacuum decay, and universe collisions, but what if there's something even bigger? What if some cosmic explosions don't just happen within the universe, but happen to the very fabric of space and time itself? There is a mind-bending concept called the Big Rip, and it represents a kind of explosion unlike anything we've ever considered. It isn't an explosion in the traditional sense. No fireball, no shockwave, no debris flying through space. Instead, it is an explosion of reality itself. Right now, we know that the universe is expanding. Galaxies are moving away from each other, space itself is stretching. But what if this expansion isn't just continuing, but accelerating forever? If dark energy, this mysterious force that pushes the universe apart, continues growing stronger, then at some point, it will begin tearing everything apart at the atomic level. At first, galaxies will be ripped from each other. Then individual stars and planets will be shredded as space stretches faster than gravity can hold them together. Eventually, molecules, atoms, and even subatomic particles will be torn apart in an event so violent that it is essentially the opposite of the Big Bang. Instead of space giving birth to everything, space itself will explode into nothingness. But here's where it gets even crazier. Some physicists believe that if the Big Rip happens, it might not be the end. Instead, it could trigger a new kind of cosmic event, one where the remnants of our torn-apart universe collide with other dying universes, forming something entirely new in a process beyond our understanding. And this brings us to one of the most terrifying possibilities of all. What if our universe isn't the first, and it won't be the last? Some scientists suggest that we are trapped in a cycle of cosmic explosions on a scale too massive for us to comprehend. A theory known as the Big Bounce proposes that the universe is stuck in an infinite loop of expansion and collapse. Instead of the universe beginning with a singular Big Bang and ending with a cold, empty void, the Big Bounce theory suggests that each cosmic explosion, whether it's a hypernova, a white hole eruption, a vacuum decay event, or a universe collision, might just be one small part of an eternal cycle. Imagine it like this. A universe is born in a massive explosion. It expands for billions of years. It reaches a critical point where it either collapses back into itself or tears itself apart. But instead of vanishing forever, the remnants of the old universe trigger the birth of a new one. The process repeats endlessly, meaning that our universe is just one version in an infinite sequence of realities, each one born from the destruction of the last. But what if there's something even more extreme than the cycle of destruction and rebirth? What if cosmic explosions don't just create new universes, but alter the fundamental rules of physics every time they occur? Some theoretical physicists suggest that each new universe that emerges after a cosmic explosion might have different physical laws. Maybe gravity works differently. Maybe time moves in strange, unpredictable ways. Maybe some universes don't have atoms or light at all. If this is true, then the most powerful cosmic explosions may not just shape our universe. They may create completely new versions of reality, each one with a unique set of rules. And if that's the case, then we have to wonder, are we living inside the aftermath of one such explosion? Did our own universe begin as the shattered remains of something before it? And if so, what existed before the explosion that created everything we know? The deeper we go into the nature of cosmic explosions, the more we realize that they might not be events within the universe at all. They might be the very foundation of reality itself. Every hypernova, every black hole collapse, every vacuum decay event could be part of something much larger, a grand cosmic process that has been happening for eternity, shaping existence in ways we are only just beginning to understand. And the biggest question of all remains, what happens next? If the universe is part of an infinite cycle of destruction and rebirth, we have to ask, are we nearing another cosmic explosion? Most people assume that cosmic destruction is something that happened in the distant past or will happen far into the future. But what if something is happening right now? What if the forces that trigger hypernovae, vacuum decays, or universe-shattering collisions are already at play in ways we can't yet detect? One of the scariest possibilities is that the seeds of the next cosmic explosion are already planted, hidden somewhere in the fabric of spacetime itself. There's a concept called false vacuum decay, and if it happens, it could destroy the entire universe in an instant. To understand this, imagine that the universe is sitting in a delicate energy state. Right now, the laws of physics seem stable, but what if they aren't? What if everything we know is just a temporary, fragile state? If a true vacuum exists somewhere in the universe, even the tiniest shift could cause our entire reality to collapse into it, like a house of cards being pulled into a void. And here's the terrifying part. This could have already started somewhere in the universe, and we wouldn't even know until it reaches us. If vacuum decay is happening, a bubble of true vacuum would be expanding through space at the speed of light. It wouldn't just destroy matter, it would rewrite the very fabric of physics itself. And because it travels at light speed, we wouldn't see it coming. 1 second, everything would be normal. The next, the universe would be gone. But what if something even more unpredictable is waiting for us? Some physicists suggest that cosmic explosions could lead to something even stranger than destruction, a fundamental shift in reality itself. There's a theory that suggests our universe may have multiple layers, or brain worlds, stacked on top of each other. These layers are normally separate, but if an extreme cosmic explosion, like a hypernova or a vacuum decay, were powerful enough, it could tear open the boundary between these dimensions. If this happened, we might suddenly experience an event where physics itself changes overnight. Maybe new particles would appear. Maybe time would no longer function the way it does now. Maybe entire regions of the universe would be pulled into strange, chaotic states where nothing we understand about existence applies anymore. And what if something is already trying to break through? Some astronomers have noticed unexplained bursts of energy, strange anomalies in the cosmic microwave background, and gravitational waves that don't fit our current models. Could these be early warning signs of an approaching cosmic event? If there is a cycle of universe-destroying explosions, we are left with the ultimate question: are we in the calm before the next storm? Or worse, is it already happening, just beyond the reach of our perception? The more we study the universe, the more we realize that destruction isn't the end of the story. Every massive explosion, every hypernova, every reality-breaking event might just be setting the stage for something even greater, something beyond anything we can imagine. The possibility that we are living in a cosmic calm before the next great explosion is unsettling. But what if this calm is an illusion? What if the next universe-shattering event has already begun, but we simply lack the ability to perceive it? This isn't just speculation. There are real, unexplained cosmic events that suggest something far larger than our understanding is at play. Consider fast radio bursts, FRBs, intense, millisecond-long flashes of energy that seem to appear at random from deep space. Scientists still don't fully understand them. Some of these bursts originate from known neutron stars, but others come from sources that defy explanation. A few even appear to be repeating at odd intervals, as if something, some unknown force or process, is actively trying to break through. What if these are the early tremors of a far more powerful event? Even stranger are ultra-high-energy cosmic rays, particles moving at speeds so close to light that their energy levels exceed what should be possible under known physics. Some of these cosmic rays carry more energy than anything we could ever create on Earth, more than what the most violent supernovae should be able to produce. Where are they coming from? Could they be the signatures of massive cosmic explosions happening right now in distant corners of the universe? Explosions so powerful that they send energy across billions of light years? But let's take this even further. We've talked about hypernovae, the vacuum decay threat, and cosmic rays that might signal distant explosions. But what if something even bigger is lurking out there? Something that could destroy or reset the entire universe in ways we haven't even begun to comprehend. Some scientists believe that our universe is not the only one. The idea of a multiverse suggests that countless other universes may exist, each with their own unique physical laws. If this is true, then what happens when two universes collide? Could a hypernova-level event occur not just within a single universe, but between universes themselves? There's a mind-bending theory known as brain collision theory, which suggests that what we see as the Big Bang might not have been the beginning of everything. It could have been the result of two vast, higher-dimensional universes crashing into each other. If this is true, then the next great explosion won't come from within our universe. It could come from outside of it. Now imagine this. If universes do collide, the result wouldn't just be the destruction of one or both universes. It could mean an entire reconfiguration of physics itself. Space, time, energy, matter, everything could be rewritten in an instant. If we are heading toward another collision event, we wouldn't see it coming until it was already happening. And here's the most unsettling thought. What if this has already happened multiple times? What if every few trillion years, reality itself is shattered and reshaped by forces beyond our comprehension? We assume that the universe as we know it will last forever. But what if we're just living in a temporary phase, an intermission between cycles of destruction and rebirth? There are already hints that the universe might have gone through multiple transformations. Some physicists have looked at patterns in the cosmic microwave background, the leftover radiation from the Big Bang, and noticed anomalies that don't quite fit. There are regions of space where the energy distribution looks strange. Some researchers speculate that these could be scars from a previous cosmic explosion, evidence that something massive happened before our Big Bang and left an imprint on our universe today. But if we are heading toward another such event, the question is, when will it happen? And even more terrifying, would we even survive long enough to witness it? There's another scenario to consider. What if we don't have to wait for a cosmic collision or vacuum decay? What if the universe is already on a slow path to destruction in a way that we can predict? Many scientists believe that we are heading toward a future known as the heat death of the universe. This would be the final stage of cosmic evolution, where everything eventually runs out of energy. The stars will burn out, galaxies will drift apart, and in the far future, black holes themselves will evaporate. The universe will become cold, dark, and lifeless, a silent, endless void. But what if this slow death could be interrupted by an extreme event? Some physicists suggest that even in this final stage, something unpredictable could happen. If the universe reaches a state of maximum entropy, where everything is spread out so evenly that no energy remains, some models suggest that quantum fluctuations could cause reality itself to break down. If this happens, then a new Big Bang might emerge from the chaos, resetting everything. If that's true, then the end of the universe isn't really the end, it's just the start of something new. But here's where it gets even more bizarre. What if this has already happened countless times? If we are part of an infinite cycle of cosmic destruction and rebirth, then everything we see, everything we know, everything we are, has already existed before, in a different version of reality. And it will happen again. If the universe has already gone through endless cycles of destruction and rebirth, then what does that mean for us? Are we just temporary fragments of existence, doomed to be erased and reformed in an endless loop? Or is there something deeper, some underlying mechanism that determines when and how these cosmic resets occur? This brings us to one of the most mind-bending ideas in physics, the possibility that the universe itself is conscious in some way. Some scientists and philosophers speculate that if the universe follows these cycles, then there must be a hidden order, an unseen pattern that governs the way reality unfolds. Could the universe be self-aware? Could it be reacting to itself, adjusting, correcting, and evolving through each massive cosmic explosion? It sounds impossible, but consider this. Every law of physics we observe today seems almost too perfect. The forces that shape the cosmos, gravity, electromagnetism, the nuclear forces, are so precisely balanced that if even one of them were slightly different, nothing would exist as we know it. This is known as the fine-tuning problem. Some believe it's just a coincidence. Others think it might be evidence of intelligent design. But there's another possibility. What if the universe fine-tunes itself? Imagine a cycle of universes, each born from the destruction of the previous one. If a universe collapses too quickly, it doesn't get to form stars and galaxies. If it expands too fast, everything drifts apart before life can develop. But over an infinite number of cycles, could the universe be learning from its past? Could it be evolving in a way that makes stable, life-supporting realities more likely? If this is true, then every cosmic explosion, every hypernova, every vacuum decay event, every brain collision, might not be the end, but rather a step in a much larger process. And that process might not be random at all. But this raises an even more unsettling question. What if we are inside one of these cycles right now? If we are part of an evolving universe, then there might be a mechanism that determines when one cycle ends and the next begins. And if that mechanism exists, then there might be signs, clues hidden within the structure of the cosmos that hint at the next great cosmic explosion. Some scientists believe we may have already found one of those clues. When astronomers study the cosmic microwave background radiation, the faint afterglow of the Big Bang, they see something strange, a pattern known as the axis of evil. This is an unexplained alignment in the radiation, something that shouldn't exist if the universe was truly random. Some researchers have suggested that this might be an imprint left over from a previous universe, a sign that we are living in a reality that has already gone through at least one major cosmic reset. But here's where it gets even stranger. Some physicists believe that black holes could be the key to understanding these resets. We often think of black holes as objects that consume everything, but what if they serve a larger purpose? Some theories suggest that when a black hole reaches a certain size, it could actually trigger a new Big Bang inside itself, creating an entirely new universe. If this is true, then black holes might not just be destructive. They might be seeds for new realities. If this theory holds, then it's possible that our own universe was born from a black hole in another reality. That means every hypernova, every extreme explosion, and every collapsing star isn't just an end, it's a beginning. But if that's the case, then where is our universe heading? Will we be destroyed by one of these cosmic explosions? Or are we part of something far more profound? The truth is, we don't know. But what we do know is that the universe is far more chaotic, far more unpredictable, and far more mysterious than we ever imagined. And if history has shown us anything, it's that every time we think we understand reality, the universe finds a way to remind us that we've only just scratched the surface. If our universe was born from a black hole in another reality, then what does that mean for the ultimate fate of everything? Could every black hole in our universe be the birthplace of another universe? If so, then rather than thinking of cosmic explosions as pure destruction, we might need to rethink them as cosmic transformations, events that create something new rather than just obliterating what came before. This idea, known as the black hole cosmology hypothesis, suggests that each black hole could spawn its own universe, separate from ours. If that's true, then the structure of reality might be fractal-like, an endless branching of new universes emerging from the remains of old ones. That would mean every massive explosion, whether it's a hypernova, a quasar ignition, or even something more extreme, could be part of a greater cosmic cycle, one that has no true beginning or end. But if this is the case, then is there a limit to how extreme a cosmic explosion can be? Is there a point where an explosion doesn't just create a new universe but instead destroys the very fabric of reality itself? Some physicists have suggested that a true end of everything scenario might involve a phenomenon called false vacuum decay. This would be the ultimate cosmic explosion, not just the destruction of stars or galaxies, but the complete erasure of the laws of physics as we know them. Here's how it works. Right now, our universe exists in what scientists call a false vacuum state. This means that while everything appears stable, it's possible that we're living in a kind of temporary balance, one that could collapse at any moment. If this balance is disrupted, even in a tiny region of space, it could trigger a catastrophic chain reaction, spreading at the speed of light and rewriting the fundamental constants of reality. If that happens, then everything, literally everything, would be wiped out instantly. No warning, no escape, no remains. Just total and absolute annihilation. This isn't just speculation. Many physicists believe that false vacuum decay is theoretically possible. The only question is when, and whether some of the universe's most extreme cosmic explosions could be a trigger. Could a hypernova, a black hole merger, or even an unknown form of cosmic explosion set off a vacuum decay event? Right now, we don't know. But the more we study these massive explosions, the more we realize that we are living in a universe that is far from stable. But what if there's something beyond all of this? What if even the most extreme explosions, hypernovae, gamma-ray bursts, white hole eruptions, brain collisions, are still just small events compared to something even bigger? There are some theories suggesting that our universe itself might be just one bubble in a much larger multiverse. If this is true, then everything we see, the billions of galaxies, the explosions of entire star systems, even the birth and death of black holes, might be insignificant compared to what happens on a multiversal scale. If universes are constantly being born and destroyed, then what happens when two universes collide? Some theories propose that this would cause an explosion so massive that it would make even the most powerful hypernova look like a tiny spark. If two universes interact, the energy released could be so immense that it would erase everything within both realities, resetting everything in an event beyond our comprehension. The question is, would we even notice if this was happening? If a multiversal collision were to occur, it might happen in an instant. We might not see it coming. Or, even stranger, we might see clues, subtle hints in the cosmic background radiation, strange anomalies in the expansion of space, or unexplained gravitational shifts that could indicate that something immense is pressing in on our universe from the outside. If this is true, then the most extreme cosmic explosions we know of, hypernovae, quasars, false vacuum decay, might only be the beginning. They might be tiny tremors compared to the larger cosmic upheavals that occur when entire realities interact. And if that's the case, then we might not be at the top of the cosmic hierarchy. We might be tiny, fragile beings living in a universe that is constantly teetering on the edge of something far bigger than we can understand. But what does that mean for us? What does it mean to exist in a reality that is so unstable, so unpredictable, and so temporary? If our universe is just one of many, then what governs the rules of these interactions? Are we simply at the mercy of unknown cosmic forces? Or is there a deeper structure to how these reality-shaking events unfold? If hypernovae, black hole collisions, and false vacuum decay are just small-scale explosions compared to multiversal interactions, then we need to ask a terrifying question. What happens when an entire universe dies? Everything we've discussed so far, hypernovae, gamma-ray bursts, black hole mergers, even hypothetical white hole explosions, are events that happen within our universe. But if universes are born and die in cycles, then there must be an equivalent to these cosmic disasters on a universal scale. One theory suggests that our universe might eventually undergo heat death, a slow, gradual fade into nothingness as all energy is evenly distributed, leaving no way for anything interesting to happen anymore. But another possibility is Big Rip theory, where dark energy keeps accelerating the expansion of the universe until everything is literally torn apart, down to the atomic level. However, if there are multiversal forces at play, then perhaps our universe won't just fade away. It might end in a multiversal catastrophe, something far beyond what we can imagine. One mind-blowing theory proposes that universes don't just expand and die, they collide and merge with each other. If this is true, then the most extreme cosmic explosion wouldn't be a hypernova or a vacuum decay event. It would be a universal collision, a scenario where our entire reality crashes into another. What would that look like? Some physicists suggest that if two universes were to interact, the first sign might be an unexplained shift in the cosmic microwave background radiation. We might notice strange gravitational waves or anomalies in spacetime that don't match anything we've seen before. And then, if the collision were inevitable, we would have no way to stop it. The force of such an impact would make the most extreme supernova look like a tiny firecracker. The very fabric of spacetime would ripple and distort as two realities tried to merge, or annihilate each other. Depending on how this collision played out, we could be instantly erased, restructured into a new set of physical laws, or thrown into a state of cosmic chaos unlike anything we've ever conceived. And the most terrifying part? We wouldn't see it coming. Unlike a hypernova or a gamma ray burst, which we can detect and study from a distance, a universal collision might happen at a scale that makes detection impossible until it's already too late. One moment, our universe is here. The next, it's not. But what if the opposite is true? What if rather than being destroyed, our universe is simply reborn through these cataclysmic events? Some scientists believe that the Big Bang itself might have been the result of a cosmic explosion beyond anything we can comprehend. If two universes collided before, perhaps that event created a new reality, ours. This would mean that rather than being isolated incidents, the most extreme cosmic explosions are actually part of a much larger cycle, one where universes are constantly emerging and vanishing in an endless loop. If that's true, then every hypernova, every black hole, every unexplained cosmic anomaly could be a clue, evidence that we are living in a reality far more complex than we ever imagined. So, the next time you look up at the night sky and see the light of a distant star, remember, somewhere out there, in the vast darkness beyond what we can see, something bigger than anything we've ever known might be happening right now. And we may never know until it's too late. If cosmic explosions are more than just random bursts of energy, if they are part of something much bigger, then what does that say about the nature of our universe? Could it mean that destruction is just another form of creation? Could the most violent events in space be the key to understanding why we exist at all? To truly grasp this, we need to push beyond what we think we know and explore something even more extreme, something that makes even hypernovae, gamma ray bursts, and universal collisions look small in comparison. Because if the universe is capable of explosions that create black holes, and if black holes might connect to other universes, then we have to ask, what happens when a black hole dies? Most people assume that black holes last forever, consuming everything that gets too close, never releasing anything back. But that's not actually true. Thanks to the work of Stephen Hawking, we know that black holes slowly lose energy over time, a process called Hawking radiation. Eventually, after billions or even trillions of years, a black hole will completely evaporate. But here's the part no one fully understands. What happens in those final moments? If a small black hole explodes, it would release an amount of energy that makes even the biggest supernova seem weak. The sheer force of this event could be the most powerful explosion ever to occur in space, something we might call a Hawking nova or a black hole detonation. This would be unlike anything else. While supernovae and hypernovae are caused by nuclear fusion gone out of control, a black hole detonation would be a quantum explosion, something on an entirely different level of physics. Some theories suggest that as a black hole shrinks, the forces within it become so extreme that, instead of simply fading away, it erupts, releasing an amount of energy beyond comprehension. How powerful would it be? Imagine taking every supernova that has ever happened, combining their energy, and multiplying it. A black hole detonation would release all the mass energy it had ever consumed in one violent instant. If even a single small black hole exploded near our galaxy, it could bathe entire star systems in deadly radiation, potentially disrupting the structure of space-time itself. But there's another, even stranger possibility. Some physicists suggest that black holes don't just disappear when they evaporate, they might open gateways. If black holes really are connected to other universes, then their final explosion could act as a cosmic bridge, momentarily linking two separate realities. This would mean that rather than being the end of something, black hole explosions could be the beginning of something entirely new. Think about it. If the Big Bang was an explosion that created everything we see today, what if it wasn't the first? What if black hole detonations are happening all the time, in different places, in different dimensions, constantly creating and destroying realities. And if that's true, then what does that say about our own universe? What if our universe was created from the explosion of a dying black hole in another reality? This idea, known as the black hole genesis hypothesis, suggests that each black hole contains the seeds of a new universe. When it reaches the end of its lifespan, it doesn't just vanish, it detonates, giving birth to something entirely new. The laws of physics in that new universe might be different, time might flow differently, even the very concept of space might not be the same. And if that's true, then what we see as destruction, whether it's a hypernova, a black hole detonation, or even a universal collision, might actually be something much more profound. It might be the process of reality itself, endlessly renewing, endlessly transforming, forever shifting in ways we can barely begin to understand. So the question is, if cosmic explosions are the key to creation, then what happens next? What happens when our universe reaches the end of its life? If the universe is part of an endless cycle of destruction and rebirth, then what happens when it reaches its inevitable end? We've explored the most violent cosmic explosions, hypernovae, gamma-ray bursts, black hole detonations, but what if the biggest explosion of all is yet to come? The fate of the universe is one of the most complex mysteries in physics. Everything we know, every star, every galaxy, every atom, is subject to the unstoppable forces of time, gravity, and entropy. If the universe had a beginning in the Big Bang, then what will be its final, ultimate explosion? One of the leading theories is the Big Rip, a catastrophic event where the very fabric of spacetime is torn apart. Unlike supernovae or black hole explosions, which are violent but localized, the Big Rip would be a cosmic-scale explosion, affecting every part of the universe at once. To understand this, we need to look at dark energy, the mysterious force that is causing the universe to expand faster and faster. Right now, galaxies are moving away from each other due to this expansion, but what if that acceleration keeps increasing? Eventually, dark energy could become so powerful that it overcomes all forces, including gravity and even atomic bonds. The process would start slowly. First, galaxy clusters would drift apart. Then, individual galaxies would begin to dissolve, their stars separating like grains of sand in a rising tide. Planets would be pulled away from their stars, solar systems would disintegrate, and even the atoms making up matter would be ripped apart, releasing unimaginable amounts of energy. In the final moments before the Big Rip, even space itself would unravel. The fundamental forces of the universe, gravity, electromagnetism, the strong and weak nuclear forces, would cease to function. In one final burst, everything would explode into pure energy. And then? Nothing. A void. A universe that no longer exists. But could something emerge from that destruction? If smaller cosmic explosions, like hypernovae and black hole detonations, create new structures, could the Big Rip itself trigger the birth of an entirely new reality? There's another possibility, the Big Crunch, the opposite of the Big Rip. Instead of the universe expanding forever, gravity could eventually win, pulling everything back together. If this happens, every galaxy, every star, and every black hole will begin to fall inward, accelerating toward an inevitable collapse. The process would be the reverse of the Big Bang. Space would contract, temperatures would rise, and eventually, all matter and energy would be compressed into a single, infinitely dense point. This would be the ultimate cosmic explosion, the final hypernova, the last black hole collapse, the grandest detonation in the history of everything. But here's where things get even more mind-blowing. What if the Big Crunch isn't the end, but a reset? This is known as the Big Bounce hypothesis, the idea that, instead of collapsing into nothingness, the universe could explode outward again in another Big Bang. In this scenario, our universe is just one in an infinite cycle of expansions and contractions, each one erasing the past and creating something entirely new. Think about it. What if this has already happened an infinite number of times before? What if the universe you know is just one iteration in an endless chain of rebirths, each explosion rewriting the rules of reality? This idea changes everything. It means that destruction isn't final. Every explosion, no matter how violent, is part of something much bigger. The hypernovae that seed the universe with new elements, the black hole collapses that reshape galaxies, even the potential death of the universe itself. These aren't just endings. They are transformations. And if that's true, then the biggest mystery of all isn't how the universe will end, but what comes next. If the universe is part of an endless cycle, then what if the next cosmic explosion is already set in motion? What if the remnants of past detonations still echo through the cosmos, waiting for their turn to ignite something new? While we've explored the most extreme known explosions, hypernovae, gamma-ray bursts, even the possible end of the universe, there's one more layer to uncover. A deeper mystery. A question that scientists still struggle to answer. What happens when the laws of physics themselves collapse? Let's go beyond hypernovae. Beyond even the Big Rip or Big Crunch. What lies at the very edge of our understanding of destruction? One possibility is the vacuum decay catastrophe, the idea that the universe is sitting in a delicate, unstable state, and at any moment, everything could be erased in an instant. To understand this, we have to talk about something called the Higgs field. This invisible energy field exists throughout the universe, and it's what gives particles their mass. It's controlled by the Higgs boson, the famous particle discovered in 2012. But here's the terrifying part. If the Higgs field isn't in its most stable state, then the universe itself could be living on borrowed time. Imagine the Higgs field as a giant landscape. Right now, we might think we're sitting in a valley, a low-energy, stable state where physics works as we know it. But what if there's another, lower valley somewhere else? If that's the case, then the Higgs field isn't truly stable, it's a false vacuum. And here's the nightmare scenario. If some event, maybe a quantum fluctuation, maybe something we haven't even discovered, nudges part of the universe into that deeper valley, then a vacuum bubble would form. This bubble would expand at the speed of light, rewriting the laws of physics as it spreads. Inside the bubble? Nothing survives. No matter, no atoms, no fundamental forces as we know them. Not even time. And the worst part? We wouldn't see it coming. Since the bubble travels at light speed, by the time it reaches us, it would already be over. One moment, everything exists. The next, gone. No explosion. No warning. Just instant erasure. But could this actually happen? Scientists don't know for sure. Some calculations suggest the universe is in a stable vacuum state, meaning we're safe. Others suggest it's metastable, meaning vacuum decay could happen, but likely not for trillions of years. But here's the twist. If somewhere in the distant cosmos, a vacuum decay bubble has already formed, it could be expanding right now, and we'd never know until it arrived. This is destruction beyond anything we've imagined. Not just a supernova, not just a hypernova, but a complete rewrite of reality itself. And yet, even this raises a bigger question. What if destruction isn't the final answer? What if, instead of ending everything, these catastrophic explosions are actually unlocking something greater? This brings us to one of the most controversial, mind-bending ideas in physics. The multiverse collision hypothesis. What if the universe we inhabit is just one of many, each one existing in its own bubble of spacetime? What if these bubbles are drifting through a vast sea of other universes, separated by unimaginable distances? And what if one of these bubbles, one of these universes, collides with our own, unleashing a catastrophe of unimaginable proportions? This is the core of the multiverse collision hypothesis, the theory that our universe is not the only one. Instead, it is part of a multiverse, a collection of multiple universes, each with its own laws of physics, its own constants, and its own reality. And just as individual stars or galaxies can collide, so too can these universes. Imagine this scenario. Two universes, each separated by vast distances, each with its own version of reality, slowly drift toward each other. As they approach, the space between them becomes thinner and thinner, and the boundary separating the two universes weakens. Then, at the moment of collision, the very fabric of spacetime is torn apart. The forces unleashed in such an event would be beyond anything we can comprehend. Instead of a simple explosion, we would see the complete breakdown of everything that holds the universe together. Gravity, electromagnetism, the strong and weak nuclear forces, all would be upended. Matter as we know it would cease to exist, and in its place, new rules would emerge. This would be the ultimate cosmic explosion. A multiversal collision would not only be a violent event in one universe, but a global catastrophe that could potentially affect every universe in the multiverse, rippling through the entire fabric of existence. But is this just pure speculation, or could there be some evidence for such a phenomenon? While we have no direct evidence of other universes, scientists have proposed several ways that a multiverse might leave a mark on our own. For instance, some cosmic background radiation might be a relic of a past collision between universes. These subtle scars could be the lingering aftereffects of a cataclysmic event that we can barely detect. Moreover, quantum mechanics and the many worlds interpretation of quantum theory suggest that every decision or possibility creates a new universe. In this scenario, every time a choice is made, the universe branches into multiple versions, each one slightly different from the others. If this is true, then the idea of universes colliding may not be so far-fetched. Perhaps the biggest explosions in the cosmos are actually the result of different realities interacting with one another. The concept of multiversal collisions also raises questions about the nature of time itself. If these universes are colliding in a multiverse, does time flow uniformly across all of them? Or could each universe have its own independent timeline, where the collision causes time itself to become disjointed? Imagine a situation where time fractures and new timelines are created, as if we were witnessing a series of reality explosions that split and reshape everything. But even this is not the only mind-boggling possibility. If multiverse collisions are happening, what might these other universes be like? Could they harbor forms of life we can't even begin to imagine? Could they possess entirely different laws of physics that would make anything we consider normal seem alien? Perhaps other universes could be so different from our own that the very concepts of matter, energy, and time do not exist in the same way we understand them. And if universes can collide, could our own universe be on a collision course with another? The potential for such a collision might seem like a terrifying concept, but it's not just about destruction. If a universe collides with ours, it may result in a radical transformation of the cosmos. Entirely new forces might emerge, new dimensions might open up, and the basic structure of existence might reboot. The collision might trigger the next stage of the universe's evolution, perhaps even leading to a new Big Bang or the creation of an entirely new cosmic order. This idea blurs the line between destruction and creation. A multiversal collision may destroy everything we know, but it could also bring about a new era of existence, one beyond our comprehension. However, it's important to note that the possibility of multiverse collisions remains firmly in the realm of theoretical physics, a fascinating concept but one that still requires much more evidence before it can be fully accepted or dismissed. But just the thought of it is enough to shift our perspective on what true cosmic destruction might be. It's not just about a single universe ending, it's about the possibility of multiple realities colliding in a cataclysmic event that reshapes all of existence. And while the possibility of multiversal collisions is still speculative, there's another equally mystifying event that might one day provide answers. Perhaps, instead of being destroyed by these cosmic explosions, we might witness the greatest cosmic explosion of all, a burst of energy so immense that it rewrites reality itself. We're left wondering, what are the true limits of the universe's power, and are we even prepared to understand them? The biggest cosmic explosion is perhaps something we can't yet imagine, a force that transcends our understanding of space, time, and existence. Whether it's the ultimate end of the universe as we know it, or the result of multiverse collisions, the truth about these phenomena may be waiting for us in the farthest reaches of the cosmos, where no one has gone before. And maybe, just maybe, the ultimate cosmic explosion isn't about destruction at all, it's about creating a new order in the universe. It's a question that may remain unanswered for millions, even billions, of years, but for now, it lingers as one of the greatest mysteries in the universe. As we delve deeper into the possibility of multiverse collisions, it is essential to understand the potential consequences for not just our universe but the very fabric of existence itself. The thought of these colossal collisions, these cosmic cataclysms, brings us face to face with questions that challenge the boundaries of science. Could a collision between universes result in the complete destruction of both realities? Or might it create an entirely new reality, where the laws of physics operate in ways we can't begin to comprehend? If we accept the possibility that multiple universes exist, each with its own distinct rules and properties, then it follows that these universes might not be isolated from one another. Instead, they might be part of a grander, interconnected multiverse, where some universes are more stable, while others are constantly in flux, their boundaries thinning over time. And, as we've already explored, when these boundaries finally break, a multiversal collision could occur, one with unimaginable consequences. Such a collision might lead to a reversal of time in some cases, where the timeline of each universe involved could be thrown into chaos. Time itself, as we know it, might cease to exist in its current form, with each universe subject to different flow rates, leading to an experience of time that is utterly alien to our understanding. Space-time could ripple and warp in ways that distort reality, creating scenarios where the traditional laws of physics, such as gravity or the speed of light, no longer apply in any consistent manner. This kind of event is not just an end but also a potential beginning, a rebirth of sorts. When universes collide, there's a chance that new dimensions could be formed, or that universes might merge in such a way that the very rules of existence are rewritten. The energy released in such a collision could be so immense that it might cause spontaneous creation, new particles, new forms of matter, and even new laws of physics might spring into being. In essence, a multiverse collision could be a cosmic reset button. But what exactly could this reset entail? If universes collide, would it simply be a violent event, or could it mark the emergence of something radically new? The potential for innovation, the birth of entirely new laws of physics, new dimensions of existence, or even entirely new kinds of life, is a tantalizing thought. Just as our universe was born out of the cataclysmic event of the Big Bang, a multiversal collision could trigger the birth of a new universe, one governed by completely different principles. This potential for creation amidst destruction brings us to a fundamental paradox at the heart of the universe's most extreme phenomena. Can the most violent events, hypernovae, supernovae, and cosmic explosions, be the source of new beginnings? Could these explosions be both endings and beginnings at once? In the grand tapestry of existence, where cosmic forces constantly create and destroy, it's possible that every violent cosmic event contributes to the overall cycle of existence, the ebb and flow of birth, death, and rebirth on a cosmic scale. Perhaps this is why hypernovae and other cosmic explosions have such a profound significance. They are not simply destructive forces. They are a form of cosmic evolution, a way in which the universe evolves and transforms itself over time. Hypernovae, with their ability to release so much energy, may play a critical role in the formation of new stars, the creation of heavier elements, and even the birth of new galaxies. Through the destruction of stars, the universe is continuously shaping and reshaping itself, creating the raw materials for new systems to emerge. And then there's the strange possibility that hypernovae, with their energy levels so far beyond anything we can replicate on Earth, could be responsible for triggering new kinds of reactions in distant regions of space. These explosions might serve as catalysts for the creation of new structures in the universe, whether that be through the generation of new stars, new planets, or entirely new types of matter and energy. The idea that such cataclysmic events could lead to the birth of something entirely unexpected challenges our understanding of cause and effect in the cosmos. But the most mind-bending aspect of all of this is the realization that we, as mere inhabitants of one universe, may never fully comprehend the vastness of the forces at play in the multiverse. The concepts of time, space, and matter that govern our reality might only be fragments of a far grander reality. As we continue to study these cosmic phenomena, from hypernovae to the multiverse, we begin to glimpse a universe far beyond our own, one where the boundaries of existence are constantly being tested, rewritten, and reshaped. In the end, The story of hypernovae and other extreme cosmic explosions is not just about destruction. It's about transformation and potential. It's about the endless possibility for change, for evolution, for the creation of new realities, new dimensions, and new forms of existence. And it's this very mystery, the profound and enigmatic nature of these cosmic events, that compels us to keep looking to the stars, to continue searching for answers, even when the scale of those answers seems impossibly vast. We may never fully understand the extent to which our universe is connected to others, or whether our universe itself is heading toward a collision that will reshape everything we know. But one thing is certain, the universe is full of untold wonders, and every cosmic explosion, every hypernova, is just another piece of the grand puzzle, a puzzle that we may one day solve, revealing the true nature of our place in the cosmos. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.